Hello, everyone, and welcome to the October 2nd, 2023 Glendale Water and Power Commission meeting. And can we start with the roll call, please?
Commissioner Fay? Here. Commissioner Kadikian?
Here.
Commissioner Laurie?
Here.
Commissioner Peterson?
Here.
President Jasmadarian?
Here. Okay, moving on to the consent items.
The next item is item 2A, approval of the August 7, 2023 meeting minutes.
Do I have a motion?
I move for approval.
Do I have a second?
I second.
Okay, roll call, please.
Commissioner Fay? Yes. Kadikian?
Yes.
Laurie?
Yes.
Peterson?
Yes.
President Jasmadarian?
Yes. Okay, next item.
Next item is 3, GWP Commission staff comments.
No comments?
President Jasmadarian, members of Commission, I don't have any comments.
Then we'll move on to reports.
Our next item is 4 reports. 4A, Water Capital Program Report.
Good afternoon, Commissioners. Richard Rule, Water Services Administrator. My turn. As we look at the capital improvement program for water, it's probably easiest to look at a summary of the major categories. The list is here. I won't go through each one because there's a slide for each individual, well, I should say the first half of the categories. Second half, I'll mention briefly because there's not specific slides for them. Security and landscape program. Let me first mention if there's a word program associated with the category, it simply means a lump sum is budgeted for that category each year, and it's used for any number of different projects on an as-needed basis for that year. If it doesn't say program, then it's a specific project that has been budgeted. So security and landscape program, we have a budget each year. Our goal is to harden the security at all our facilities, whether that be improved fencing or motion sensors. We've done that at the Grandview Pump Station kind of on a pilot basis to use as an example for possible other facilities. Landscaping, as we do this, the hope is to improve landscaping where needed at each facility with drought-tolerant landscaping. Western Reservoir would be the recent example. You may have noticed extensive new landscaping around the Western Reservoir, which is between Western and Ramsdale, just south of Mountain. Valve replacement program, hydrant replacement program, those are simply replacements done on an as-needed basis. We have a new SCADA radio system we're putting in. That's a 900 megahertz radio system, and then meter endpoint replacement program that we are ongoing with to replace some of the endpoints. So probably our major CIP category, and the one we're most known for, is replacing pipelines. This is a typical trench you see around town. This is a ductile iron pipe that's replacing an old cast iron pipe. I brought some visual aids. Show and tell, just like my children. Why do we replace old cast iron pipes? Well, here's one reason. This accumulation is known as tuberculation. It is most prevalent, or farly most prevalent in cast iron pipes. This is actually a bacteria-driven reaction. Bacteria reacts with the ferrous oxide in the water to create precipitation, resulting in these tubercles, they're called, from tuberculation tubercles. And over time, they build up and constrict the flow and pressure in the pipe, which is a big issue in cast iron, old cast iron pipes. So the solution, our preferred replacement product, is ductile iron pipe, which has a cement mortar lining on the inside, which prevents tuberculation. This actually is, it looks like it's not ductile iron, it's also cast iron, but the other option from replacing cast iron is to remount the tuberculation, and you can actually inject a cement mortar lining in the in-situ pipe in the ground. So that's an ongoing effort at about $8 to $10 million a year. And looking at a summary of recent PMP, as we call them, pipeline management projects. This was last year's. You can see where in town we replaced pipes. The priority, as identified in our master plan, is to replace 4-inch and 6-inch diameter pipe with 8-inch ductile iron pipe throughout the city. We like to group them geographically together if possible, but that's not always possible. As you can see, these pipe replacements are spread out. The priority, again, is to replace the 4- and 6-inch pipes. This is last year's project. This is this year's project. You can see we're replacing a pipe at about $1 million a mile. And this is next year's project, the Chilton-Kenneth area. So this is ongoing. It'll be ongoing for forever. Tank rehab program. We inspect our tanks and reservoirs every 5 years, depending on their condition. They're slated for rehabilitation. This is the Glendale recycled water tank. The rehab always includes sandblasting of the interior and repainting. You can see the before and after pictures. Also, there's a number of other improvements made at that time, usually sandblasting the exterior too. In addition to the tanks, we of course inspect our reservoirs. We have a lot of wooden roof reservoirs in the city, and all of these wooden roofs are pretty much at the end of their useful life. This is the Western Reservoir. We have a preliminary design report done to replace this wooden roof. Well, actually, we're looking at several options. One of the options, which is probably on the higher likelihood of being implemented, is actually installing 2 steel tanks inside this reservoir and not replacing the roof. And there's several reasons for that, but that's one option being looked at. But we're in the process of evaluating all wooden roofs and prioritizing the different options available for replacement or rehab of those roofs. This is a concrete reservoir. This is the western side of Glorieta Reservoir. It's actually right underneath the baseball fields in Glorieta Park. You can see the blemish or the cracks in the floor there. This is typical degradation of a concrete reservoir. The sealant between the concrete, in the concrete joints degrades over time, allowing leakage through the bottom of the reservoir, which is just revenue loss to the city. So, and actually this project will be coming to you soon for authorization to bid. It, of course, will involve replacing the sealant between the concrete joints. The pump replacement program, we have 30 pump stations in the city, and the pumps periodically need to be replaced or rehab. This is simply an example of a new pump being installed. This is, again, at Glorieta Park. That's about a 400 horsepower pump. One of my previous presentations, I talked about local water resource or local sources of water. Here are two examples. The Foothill well on Foothill Avenue near Lauderdale. This is an old agricultural well that was repurposed for potable water many years ago. Its production has been declining significantly in recent years. So we were looking at drilling a new well at that same location. But the logistic challenge of that is so great, we're looking at a possible another option of rehabilitating the existing well. And we're right in the middle of evaluating the cost benefit of each option. It looks like rehab of the existing well is not going to work out. We think the casing that has since been lined by a PVC liner has collapsed, making that well essentially useless. So drilling the new well is the option we're looking at, and that's not a cheap option. It's estimated at about $1.2 million. More hopeful are two existing wells at the UOC, the Utility Operations Center, where the current demo of the Grayson plant is ongoing. There are two wells there that previously had been used for recycled water to use as cooling water in the power plant. That's no longer needed, so we hope to repurpose those wells as potable wells. You can see one of the old casings on the right there in the midst of the demo. There's several logistical challenges ahead to make this happen, but we're hopeful that it is an option. And this is hugely significant in the savings that might incur with this new local source of potable water. These two wells, you can't see the second well, but the two wells together amount to about 2,000 GPM, so we'll say 3,000 acre-feet a year. That'll save the city about $1.2 million a year in imported water. So I'm excited. Slope repair project. Many of our facilities, reservoirs in particular, reservoirs and tanks are up in the hills. There's always an access road to get to those facilities. They're usually on steep grades, and there is ongoing erosion or damage to those access roads. So we have a program to address that. On the left is the road across the face of the Brand Park Reservoir. That's a completed project on the left. You can't see it in this photo, but the old asphalt road going across that span was constantly crumpling off down the hillside. It has been replaced, repaired, with not just a concrete curb on the edge, but they call it a deepened concrete curb. So there's a concrete slough wall beneath that curb you see there, which should last for certainly my lifetime, probably my kids' lifetime too. On the right there is that same access road further down the hill. This is damage from the January 20th storm, which was that really big storm. So this repair is under preliminary design. That damage actually was identified or qualified for FEMA reimbursement, so it's possible, it's likely that that work will be reimbursed by FEMA. And that's it. I wanted to keep it short. Questions?
Thank you. So I will entertain questions.
I've got a couple of quick ones, just for my understanding on some of these things. With regard to our water distribution, the pipeline system, you hear a lot about, not just here, but the whole danger of people hacking into our infrastructure. Based on sort of what you were sharing, it doesn't look like it's very hackable. Am I right in
By hacking, do you mean
that you've got
cyber, or?
somebody in an overseas location that can somehow go ahead and get into our control systems and shut down all the water pumps in the city or something like that? That doesn't seem very feasible with our system.
Probably not, but we have a whole cybersecurity effort that is not strictly part of my duties, but cybersecurity is a huge priority in the city. Physical hacking, if you mean stealing water, that would not happen from a buried lateral or main like you saw in that one photo, but it does happen on service connections. We've seen that, so that's an ongoing effort to monitor and mitigate that.
Okay, thank you. And another quick one that I had is on the PMP, or the Pipeline Management Program, all these replacements that you do, is there like a revolving schedule that you have, or is there, or maybe a combination of that along with visual camera inspections? How is this determined?
Well, the prioritization process happens through the master plan. That's based on age, condition, diameter, maybe a few other factors. From the master plan, we know which are the highest priority pipes to be replaced. And our budget, like I said, is about $10 million a year. So yes, it cycles from year to year. It's constantly ongoing. One project leads to the next.
Sure. And then my final question on this is just with regard to our reservoirs. Again, these are very infrequent, but they're always tragically spectacular. And is there any kind of realistic risk associated with our levee failures with our reservoirs?
Yes, that's interesting you should ask. Again, that's all regulated. And the regulations became even more stringent after the Oroville situation, whereby we were required to write an EAP, an emergency action plan, for each of our reservoir embankments that qualify as so-called dams by the Department of Safety of Dams with the state. And there's 5 of them in Glendale. And so each one has an emergency action plan which identifies exactly what response will happen if there's discovered damage to one of those dams. Along with that, we were required to create inundation maps. Where would the water go if a dam catastrophically failed? So all those areas have been identified, the velocity and the speed of the water that would result, the risk to residents. That's all been regulated, and we have to adhere to those regulations.
Sure, I guess, so are we also, those are steps that identify sort of what will we do if things went bad?
Yeah.
And where would it go bad at, and who would affect? But are there mitigating steps? I mean, for instance, are we doing more things? I mean, typically the ones that have failed that were thought to be safe was that they had some sort of like liquefaction that was unknown, et cetera, because they hadn't anticipated that there would be, groundwater penetration at some level. Do we do borings or anything like that at some basis to check?
Liquefaction risks have been done. Historically, there's no liquefaction risk for our so-called dams. There is constant reconnaissance by our field people on the condition of the dams, I would say on a daily basis. DSOD, again, requires annual inspections where they come out and thoroughly inspect each dam. The major mitigating factor, I have to say, is gophers boring into the dam faces. That's, again, something DSOD requires that we mitigate. There are no trees allowed on those dam faces, so there's no possibility of root damage.
Well,
So
thank you.
it's under constant.
I just wanted to know that we have a prevention and inspection
Right.
program, not just an after-action
Oh,
plan.
I understand.
Thank you.
A lot of ongoing reconnaissance and evaluation, yeah.
Thank you.
Any other questions? Sure. Okay.
Thanks for the presentation.
Yes.
Is that 10 million or 8 million a year, is that enough to keep up with the pace at which pipes are failing? Are we falling behind? Are we keeping up? Are we treading water? Are we getting ahead? How would you classify that?
Well, let's see. we always have pipe breaks every year, every month, well, most months. Are we keeping up with those? I can say we are replacing as much as we can the pipes that are most at risk for breakage. Are we keeping up? You know, this replacement of aging infrastructure is a huge challenge, not just for us, but across the country. Every infrastructure piece is coming due for replacement kind of at the same time, where a lot of things are 100 years old. So, yeah, could we use more money? Sure. But, you know, we have to operate within the constraints of a governmental agency. But it'll take a long time to replace all the 400 miles of pipe in the city. By the time we do, it's going to be time to start over again. It's that kind of cycle, really, for infrastructure.
Yeah, I think it's germane in the context of a later discussion we'll have on the electric rates and, you know, what happens if you don't take care of that infrastructure, right, for 100 years, right? Now you have to pay for it, and are we saddling the next generation with that cost? So I would like to see that we're making sure that we pay our fair share for the timing and the failure of infrastructure during our, you know, lifetimes or our presence here in the city.
Yeah.
And I imagine the replacement materials we use have a longer lifespan than the materials that they're replacing.
Ductile pipe has a longer lifespan than cast iron, yes.
So once we've completed the full citywide replacement, then maybe the replacement cycle can extend?
Well, yes, but I would have to say not significantly. Lifespan of cast iron, 70 to 80 years. Ductile iron, 100 years, that kind of thing.
So it's not a huge percentage increase?
No.
Okay. Looking at this summary of the budget and these line items, a lot of these seem like kind of heavy infrastructure maintenance replacement projects, but I don't see anything in here that's kind of expressly about developing local water sources or improving water efficiency. I know you mentioned some of the co-benefits of sealing reservoir and things like that, but have we ever budgeted through the capital improvement plan something like, you know, a local water source development project or extending the purple pipe or water efficiency projects? Are those ever part of this process?
Yes, extending purple pipe is part of the master plan. There's been certain projects that have been identified as good candidates. Local water resource options, I think, like I described previously, are very limited. I wouldn't say it's a part of the capital improvement program, but we have a hydrogeologist consultant under contract who's charged with that exact task to look for, research possible local resource locations.
So if we look at you know, what those projects might be, like I know there's some legal issues around stormwater capture and who owns the rain here, but if we decided we could get some relief on that and we wanted to spend $5 million to build a stormwater catchment system here, is this how we would fund it, through this CIP?
It would be budgeted through the CIP budget, yeah.
Okay. And likewise, if we wanted to make an investment in water efficiency, maybe something like helping reduce non-functional turf, which I believe we have an obligation to help administer that state requirement. Is that something that we could fund through the CIP, like grants to public agencies in Glendale or something like that?
I don't know. I might look to Mark for this. CIP is generally thought of a project that is depreciable, can be depreciated over time. I'm not sure turf replacement falls in that category now.
Yes, turf replacement would be part of the public benefits. So that's taken, while many times public benefits, everybody thinks of it as electric, there is a component of water too. So, and turf replacement is part of that public benefit program.
Gotcha, okay. And I noticed that there are some kind of cost effectiveness metrics we might derive out of this plan. Like if you look at how much we're spending at the Glorietta Reservoir to fill those cracks, right? it sounds like that's a really good way to reduce leakage from the
Yes.
system.
Yes.
Do we have a sense of like the cost effectiveness, like how much, what's the dollar per gallon saved on something like that? And how it
Yes.
compares to other water saving projects we do?
I have calculated out the savings from the estimated leakage. We have an under-drain system for each reservoir, which actually collects any leaked water, daylights it, so we can see how much water it is. And that has been measured. I don't have that calculation in front of me, but, it was significant. I won't say that's,
Snow as a
I will.
follow-up? Because I
I
think it
will.
would be interesting to see how much are we spending to save a gallon of water there versus how much are we spending to save a gallon of water at a customer's shower or
no, I understand.
on their sprinklers or something like that.
That's a good point. Cost effectiveness, yes. But when we drain a reservoir and inspect it, and we see something like that, we're gonna fix it regardless of, the possible or the end result in savings, because if you don't fix it, it's gonna get worse.
Sure. Okay, thank you very much.
But
Thank you for the presentation. It's not more of a question, but just a suggestion or a comment for future presentation. I know we talked about pump replacement and reservoirs, and it would be beneficial if we can see those pumps and those reservoirs on a map and which communities they serve.
sure,
The reason for that is, to a certain extent, I'm always concerned about distributing the cost fairly and equally, and I'd like to see how these pumps are located and and the reservoirs, because they cost money to operate, keep up, and electric power to pump, and what areas they serve, so that the cost is properly allocated. In my mind, and this could be completely wrong, but I kind of see these pumps pumping water up the elevation on these high mountain houses, which I could be wrong, but I'm just saying. And here we've got $2 million, $3 million houses, water being pumped all the way up to them, and everybody paying the same amount for the water. It sounds to me there's an issue of fairness or equity when we've got apartment buildings in downtown paying for water to be pumped all the way up to multi-million-dollar homes. So I'm not saying that's happening. I'm just saying that's something visually kind of occurs to me sometimes. And I'd like at some point to have some sort of a presentation where it says, these are the pumps we have, and these are the areas they pump water to, and these are the reservoirs we have, these are the areas we have them in, and what's their purpose there. Maybe it's just to have water, or maybe it's just to fight fire, and just to get a better idea of cost allocation, in my mind. I could be all wrong, though.
Commissioner Kaviki, I think when we do the cost of service study for water, that would be a little bit more appropriate for us to be able to talk about that. And if we were to, if we socialize the cost of pumping, we also socialize the cost of moving electricity also.
Yes. I agree, and electricity is even more, particularly if you've got to pull miles and miles of cable to get electricity all the way different locations.
no, they're good questions. A couple of thoughts. As far as adjusting rates to the elevation you live at, for instance, I think that was discussed, or at least considered, addressed at the last COSA, the rate study, but I think it became a legal question of sorts. But I know that question has been talked about in the past. But know this, a reservoir at a high elevation, first of all, our facilities, pumps and reservoirs, serve pressure zones. They don't serve neighborhoods. They serve pressure zones, which cuts across any economic, social neighborhoods. And the benefit of a neighborhood that's served by a reservoir at a high elevation, that serves the whole city. I mean, if water used there means it doesn't have to be used elsewhere. So it's one system, in my mind, that benefits the whole city.
I guess just the way that these things tend to be designed, as I understand it, is you create a pressure for the whole thing. So you put the reservoirs way up high, and it's the weight of the water that then creates a pressure in the entire piping system that then does it. You don't have pumps that pump up to specific houses or neighborhoods. So you're not having a low static pressure and then just having pumps to go do it. You tend to have large gravity feed that goes and puts the weight of the water that creates this. And then the difference between potable water and what you have for a fire line are completely separate, but similar ideas. And to the extent that you have pumps, it's to pump water then back to the reservoir. And that's a relatively small amount. You can pump a little bit all the time to keep a certain level, but it's really the reservoir water pressure and weight that creates the ability to pump elevated. And this is sort of what the Romans pioneered by taking water from high mountain lakes and being able to go ahead and use that to get Rome water.
Thank you. I guess that's why I prefaced my question. I could be completely wrong, so thank you.
Any other questions? Okay, so I have,
You mentioned the roofs on the reservoirs and replacing those. Are those candidates for dual use applications? You mentioned there's a baseball field at Glorieta. Could they be hosting solar energy facilities or other things?
They are being evaluated for solar energy, yes.
okay. How old is the oldest pipes in the system?
I would say the 20s, maybe even pre-20s.
Okay,
So over 100 years.
okay, so that's still not bad. And as far as the Western Reservoir, so I see the budget is 96,000 for all the storage. I'm assuming that that's very little construction. Basically, it's the work on Glorieta. And then this must be further study and analysis that's going on with Western Reservoir?
Yes, that's simply for the preliminary design and design, yes.
Okay. And then one more question about the wells. So if the USC wells are repurposed and it's going to become potable, what is the water quality in that
Well,
area?
Good question. That's kind of an unknown at this point. The last sampling was possibly 10 years ago, and there was one hit of VOCs, so we haven't resampled since because of the logistical challenges with the demo of the power plant. But my view, regardless of the quality, it can be treated, whether that's another carbon vessel like the Glendale water treatment plant, or, well, if it's chrome 6, then it would require, a air stripper and resin removal. But regardless of the cost of treatment, I think there would still be a savings. That's kind of why we're going ahead. You can always treat for water quality. What you can't always do is find a producing well. These are very valuable wells, given their production.
Thank you. That's it.
Thank
I'd
you.
like to make one clarification. Richard indicated that the Glorieta Reservoir Repair RFP would be coming back to the GWP Commission. That was inaccurate.
Okay. Okay, next item.
Next item is 4B, Electric Capital Program Report.
Good afternoon, Commissioners. My name is Daniel Scorza. I'm the Chief Assistant General Manager for the electric side for Glendale Water and Power. So today I have a sampling of projects from our capital improvement program report. It's got some of the budget numbers. And these are 4 big projects. In general, our big electric projects are in our budget. And in general, I think when they talk about the COSA and the bigger programs, the entire budget is in there. But here, we'll just show you 4 projects. So let me start off with 4 projects that I'm going to discuss. So here's just a sampling, and it's the budget that we had for this year. So we got the Shoal Biogas Renewable Generation Project. We had $35 million for this year. City-owned solar development program. That's the big solar program that we had been working on, where we had an assessment, and this is our phase 1. Our 12 kV feeder reconstruction project. This is changing our 4 kV feeders to 12 kV. And this is an ongoing endeavor. It's about $7 million, and that's per year. And then the fleet and building electrification, about $200,000. This is just for the study part, and I'll discuss a little more as I get into the slide for the specific item there. So I'll go on to the next slide. So this is our Shoal Biogas Renewable Generation Project. We put a project cost about $90 million. The entire project is being built for around $73 million. There's additional dollars in here for O&M. Again, it hasn't been built. We haven't been operating it, but that can vary depending on the cost of maintenance. So right now, there's about $20 million in here. That's why we got 90. It could be a little higher or a little lower, depending on what O&M actually is. And we won't know that number until we actually start operating it. The benefit is that it will utilize landfill gas. It'll provide up to 11 megawatts of local generation, so there's no transmission associated with this, which is a big plus. Being Glendale, we're sort of landlocked. So this is a big plus for this project. And then we're looking at a completion date of May 2025. We had a big scheduling meeting together today with our project management team, and we still have that date. So I'm very happy to report that we're still on schedule for May 2025 to complete it. I'll go on to the next project. This is our city-owned solar development program, phase 1. We had an estimated project cost of around $15 million. There it's $14,650. This project aligns with the city's clean energy goals established by the City Council in August 2022. We're looking at 6 sites and about 3.7 megawatts. And the completion date, it's sort of fungible, meaning that it's sort of a hopeful date that we would finish everything by the end of 2024. And that's also a crucial date in that if we start the project in 2024, so we're in 2023 now, right? But if we start the project by 2024, then we're eligible for the investment tax credit through the different programs that the federal government has. So we want to make sure we start the projects by that date. So that makes us eligible for 30% of the total project costs being given back to us. So we're looking forward to that. I'll go on to the next project example. This is our 12 kV feeder reconstruction project. We're currently budgeted to spend $7 million annually. That was the general cost for about 4 or 5 feeders per year. It's about $7 million. The benefit of this project is that we're converting our 4 kV feeders to 12. And what does that mean? That means that we can carry about 3 times more amount of power on the same distribution circuit. Why? Because the voltage goes up, current remains the same, and it's a modification of the existing poles and cross arms and wires. We just spread them apart, put bigger insulators on them to insulate them for 12 kV instead of 4, and we can carry more power. Now, this is just the cost to upgrade the circuits in the city. We have about 100 feeders, So about 50 feeders, now about 55 feeders are at 12 kV, and there's about 40 or so feeders at 4 kV, and those are the ones that we're converting. Now, further is that we have other project items where we're upgrading our substations because the substations need to be upgraded to carry the higher amount of power. So that's a separate item. But in here, we're just showing you what it costs to upgrade the feeders in the streets, our distribution feeders. We're looking, because we had, when we started this, we had 50 feeders. So 5 feeders per year, then it would be 10, but we are making great progress. We're doing more than 5. So we're probably looking at maybe 6 years to complete all this, 6 to 7 years, if we can keep up with the project. Unfortunately, one thing that's happened is that because of the supply chain issue, electrical components are hard, including poles. They're hard to come by. We're working very hard with our vendors and our team to be able to get the parts to continue the output that we're doing now in terms of construction. So let me go on to the next project. This is our fleet and building electrification. The biggest component of electrification is probably EV charging. Those are probably our biggest loads. I don't know if you're familiar with EV chargers. A level 2 charger is what we have in our home. It's anywhere from 7 to 11 kilowatts. Those are what you can plug in your electric car at home. But 7 to 11 kilowatts is equivalent to a home. So each time we add a feeder, EV charger at home, it's like adding a house to the grid. So they're pretty big. Now, what we're doing here, this is for the infrastructure at our facilities in the city. So EV charging for the city fleet, especially buses that we have with our Public Works department. They have about 60 buses. Those chargers are bigger, and those buses are bigger, so they require larger chargers. Associated with that, just like, say, a company like the Tesla or Electrify America, when they come to us and say, GWP would like to use a parking lot and put EV chargers on there, we look at the project and they say, well, can you provide this amount of power? We have to do that with each city department at their facilities. We're estimating that cost to be around $21 million. So that is the cost that the total city would have to come up with for us to provide them the power, just like any electrical customer. It's an estimate. We'll be working with our consultants to refine that. But the main point will be that each city department will have to hire their own facilities designer, come to us, talk to us, tell us what the requirements are, and then we'll see what we need to provide them, how to provide them with the power they need. In some places, like for example in the bus depot where they may have 60 buses, we may only have 1 feeder in the area. We may need a second feeder. Therefore, we would come back to the city department and say, listen, we're short 1 feeder. You have to assist in the expansion of a feeder. And so then there's the added cost of putting a new distribution line to them, so now they can be fed by 2 lines to allow them to have enough power to charge, example, 60 buses. But anyways, that's what this fleet and building electrification requirements have. And again, you're aware that at the beginning of this year, we passed our electrification REACH code that requires all new construction in the city to be all electric. So we're kind of following up on that with these programs, although the fleet electrification will take longer because it's a longer horizon item. And then, of course, the commission's familiar, by 2035, no new internal combustion engine cars will be sold in California. So therefore, we'll be looking more and more electric, being the only way to have a fleet vehicle to be able, and then we have to provide the required infrastructure to provide power for the facilities to charge vehicles. And That's my presentation. If you have any questions, I'll be happy to answer them.
Thank you. Any questions? Okay, Commissioner Fay?
You mentioned the investment tax credit for our local solar. Are we able to take advantage of the 10% bonus for low-income communities?
I think we'll be looking at every possible way of maximizing that, including, I think, using union labor as well. There were
also,
provisions for that.
Yes, and also local content in the equipment. So let's make sure we're checking on all those and see if the cost benefit is worth it for the extra tax credit. That's
right. Well, also, we'll try to see we get local providers as well. So we're looking at every way to maximize it. So we're very well aware of the program. Our program manager is very aware of all the rules and regulations. We'll be maximizing that.
That's great. Okay. And will any of those solar facilities be paired with energy storage equipment at those sites?
Right now, our biggest energy storage project is at the facility. I don't know if Mark wants to say something about that.
Sure. When we get the 300 megawatt battery over at Grayson, we need some ability to charge that. So we're looking at these solar systems being able to charge that battery first. When we need to then start putting batteries on, hopefully the price of batteries will start to decrease, and then we can start putting batteries in various substations throughout the city. But right now, we're looking at trying to get as much solar penetration as possible, and then given the fact that we have 300 megawatts of battery. So that's our first goal, keeping an eye on local battery pricing.
And I imagine from a site selection perspective, the sites that are good for solar aren't necessarily good for large-scale batteries, right?
That's correct. We're looking at potentially putting a battery up in the Montrose area because the generation is down in this area, so the voltage support would allow us the capability of being able to use the battery for energy and voltage support up there, but it's not something that we would be doing right this second.
Gotcha. Thank you. And on the cover sheet, it says there's $200K associated with fleet and building electrification, and then you said there's $21 million paid by customers, and I think the first customer there is the City of Glendale Public Works Department, right? So what is the $200K that our department is paying for?
Yeah, so the $200K is for our study. So we're doing a capital improvement project to look at and identify these projects and what the requirements would be, but it's a very high-level estimate. The specific one for each department will be done by each department. They'll come talk to us. We'll tell them what's available in the area, and then we'll work with them to do a final design. And if there's a need for them to help us with the infrastructure, we'll let them know at the time, but also we'll let them know what the cost is for us to extend our lines into the facility, because there's always work locally on the area where they're going to be building the parking lot, just like any other building. There may be, there's an electrical room, there's a conduit going into that area, and that's normally paid by the customer.
Great. So that study, that's a citywide study of general EV readiness or kind of load growth forecast and impact on infrastructure? Yeah,
it's just a general estimate of what it would cost. It's going to be a rough number. Right now, we estimated it was rule of thumb. We just put it together very quickly, came out to around 21 million. We want to refine that. So we're asking this owner's engineer firm to refine that as best as possible. It may come out very close to that number.
I see. Okay.
Yeah, and again, it's not the final number. The final number is when they do the design by the actual owner's engineer for each facility, each department.
Great. Okay. Thank you.
Any other questions?
I just wanted to make sure thank you again for the presentation, and really fascinating on a couple of points. One is your comment that the 7 to 11 kilowatts for an EV charger in the home, that's assuming one car that's electrified?
Yes, one EV charger's anywhere 7 to 11. 11 is the higher end level 2 charger.
But that's the capacity that it does, but if you're not charging anything on it, it doesn't draw power.
No, that's right.
So
you have
you're
to plug it
assuming
in.
one car, the equivalent then, the consumption of a house that we've historically had without electrified. So if a household gets 2 or 3 cars, each car represents an entire household.
That's
Is that
right.
what you're saying?
That's right.
Okay.
That's correct.
Right. So what we had was then historically a capital improvements program for the electric grid that was predicated on population growth and housing growth that would draw electric demand. And that's what we built our infrastructure based on. And the monies and the budgeting for future projections of how much would have to be invested to keep up with demand. But now we're suddenly having a major inflection point that is an order to a magnitude almost. Am I understanding this correctly?
Yeah, that's correct. So one of the things that's going to happen, like the REACH code requires now, if you build like a 500-unit apartment building, 50% of the parking spots will require to have a level 2 charger there. So before we wouldn't have that load. It's 500 times 7. I mean, 3.5 megawatts. So
That's assuming a certain base level, but what you're saying is that that's a baseline assumption, but if you then have multiple vehicles, then that's going to be drawing a certain amount continuously rather than at certain hours. So it could be higher?
Commissioner Peterson, I think we need to clarify a little bit. If you have 2 EV vehicles and 1 charger, then it would only be 1 charger. So you wouldn't have to do it. The only time you need to be concerned with that level of increase is if you had 2 chargers. I don't anticipate somebody having 3 chargers, but if they had 2 chargers, they're tripling their load because of the potential for plugging those cars in and using your normal city, your normal household load. So it's really chargers, not vehicles.
Got it. So it's the maximum capacity of throughput is what you're looking at there. So,
Correct.
okay.
And that's what, as a utility, that's what we have to plan for. We have to plan for everybody using their electric at the same time. So it's a capacity. So we would have to manage that capacity.
And then
And I might add, I think that's a differential distribution around the city. There are, I think, are certain neighborhoods that have adopted EVs with, higher rates sooner, and certain transformers, that are powering 5 houses and 10 EVs, where other transformers may be just 5 houses. And I think one thing that concerns me is we don't really have a great idea of where all those are and how they're being used, right? That's kind of an unknown to us because we don't have the access to that data.
yeah, although I don't know if our folks that do the estimates on DER and future programs, they're looking at something like that, right?
Well, they're developing software to actually try to anticipate what the growth is on EV penetration, but that's a very active market right now, so we're keeping an eye on potential increases. Unfortunately, I wouldn't want to be the person that would
move around. We need to move more, I think.
I think we need to upgrade something.
It's time to loosen the tie. I wouldn't want to be the person that would actually cause the distribution system to have to be upgraded because I decided to put an EV charger at my house. So, I mean, those are the things that we're trying to address. And by going from the 4 to 12 kV, it allows us a little bit of leeway to allow people to put electric vehicle chargers in their house without overloading the distribution system, or i.e. paying for an upgrade of the distribution system.
So
But, yeah, go.
So if everybody has 12 kV on the entire block, they could have 2 chargers in their homes, plus their home, and they'd be okay? Or are we going to have to upgrade even further then?
I think the owner's engineer would actually have to take a look at the study and to find out how much penetration of EV penetration we can have on each feeder, and maybe actually field switch some of the distribution feeders to allow for that. But if the anticipation that everybody is going to have 1 or 2 or 3 EVs in their house, that's something that I don't think any distribution system is able to handle at this moment.
And another way to handle that is through managed charging. These vehicles don't all need to plug in and charge at full speed at the same time. If you're driving maybe 40 miles a day, you probably only need to be on your charger about 30 to 60 minutes when you get home to top up your battery. So if every neighbor kind of took turns charging overnight when there's lots of available power.
Who's going to be the one at 2 a.m.?
So there are some smart chargers that can manage that, and there are some software programs that can actually coordinate that without the neighbors communicating with each other, right? And the utility can play a part in that. So I think there's a lot there where the data and the software can increase our effective capacity of our infrastructure.
Yeah. Just a note, being the utility, I mean, I've been asked, Dan, yeah, you don't worry about that because we have software management systems that will allow sharing of the existing lines. The problem is that when somebody upgrades their panel, they say, well, I'm going to have 2 EV chargers, I'm going to electrify the kitchen, I'm going to get solar, I'm going to put a battery in, I'll have an electric or a pump, what's the heat pump? Yeah, heat pump, water heater and stuff. So I'm going to upgrade my panel to 400 amps from 200 amps. The thing is, when they upgrade the panel, I have to upgrade all the infrastructure on the utility side. And so I've been told, well, Dan, just wait. The load won't materialize. But I can't come back, 10 years later or 5 years later when it materializes. I have to upgrade the system as they pay me. Same thing with buildings, same thing with streets. As you double the load, I have to double the infrastructure to deliver it. Eventually, I have to double the generation. So the infrastructure has to go in. Now, when is it cheapest to do this? It's at the beginning. It's when we first do it. If I have to come back and do it afterwards, it's going to cost a lot more. So that's the dilemma we have as a utility. As they pay for upgrades, as a building owner, developer comes and says, I want all, 50% of my parking spots to be EV level 2 ready, regardless that we use a software management system, I have to put the infrastructure in there because they're paying for that. They're saying, I need this amount of power. So I have to upgrade it all the way back to the utility. And so that's the dilemma. The infrastructure has to be put in at that time. So
I
regardless
guess,
they use it or not at that instant.
That's sort of 2 more points I was going to touch on. One was, we understand when we're trying to model demand and all these things, but at the end of the day, we have an endpoint. If we're not going to sell anymore, if it's illegal to sell internal combustion engines in California starting 2035, and just the 12 kV upgrade is going to take 6 years. So we know in 2023, come 2030, we'll have just upgraded our 12 kV across the 40 distribution circuits that we have, the feeders. We haven't upgraded our generation to match that at that point. And we know that, yes, you stop selling in 2035, but people can continue to own and they have what they have. So useful life, maybe another 10 years for the vast majority of internal combustion beyond that. So we could know that by 2045, you're going to have the generation and distribution, and then you can do either a linear or an algorithmic path of development and figure out. So I'm just saying that we don't have to wait for demand or model it. No. We can do a backward engineering of what might be the kind of capital expenses we need to do. The real part that I wanted to ask about, really the final point, was as we electrify, particularly our fleets and particularly the public transportation, since public transportation serves the most vulnerable and often the most in need, who have little other choice beyond that. So as our grid gets maybe potentially less reliable, we're going to move more and more of our vulnerable people onto more unreliable fleet transportation, because when the grid goes down, buses don't get charged. Do we have any way to mitigate that? As an example, for instance, and I don't know what the law says that, will the municipality be still able to purchase in 2035, say, police black and white vehicles that are gas powered? I mean, I manage a fleet of vehicles and I manage a police department, and my police chief was saying, we can't electrify our squad cars because if we have a seismic event and the grid is down for a very lengthy period of time, we still need to have our vehicles. I'm like, I understand we have 3 pumping stations that you can get your gas, but they run off of electricity. So we've had to go and put in backup generators on our pumping stations. Do you have a similar backup for to be able to charge up these buses if your grid goes down for an extended period?
We don't. what makes matters worse is all of our repair vehicles have to be electric. So we've been fighting AQMD about this, that they don't build an electric vehicle that allows us to have a boom truck to be able to fix. And they were like, well, that's too bad, you only can buy an electric vehicle. Because we're not considered safety. If we were considered safety, then we would be able to have a certain amount of internal combustion engine vehicles in order for us to do what needs to be done. Police and fire are allowed to maintain their internal combustion engines. One of the things about mutual aid, I think IID had a problem with their polls a year or so ago, and the people that had electric vehicles couldn't provide mutual aid because their power infrastructure was down. So we're fighting this all the way up, excuse me, all the way up the state to try to carve out a certain amount of vehicles in our fleet that maintain internal combustion engine status so that we can provide mutual aid in the event that there is a major
Or you're going to
catastrophe.
end up having to do things like have those vehicles carry around portable gas-powered generators to generate the truck electricity when it can't generate it itself and the battery's dead. Now you're going to be generating more CO2 gases than if you had just done it on a central basis. Just saying that we've been looking at those same kind of problems ourselves, so.
In the case of the public transit fleet, there are some pretty straightforward solutions because buses generally charge at the same time and in the same place. Many depots have been installed with stationary energy storage devices, very large-scale batteries that can serve as a buffer between the buses and the grid. So if there's a short-term outage, the buses charge off the battery, and then that battery also provides grid stabilization to the grid when it's not needed for emergencies. And some of those have also been fitted with large generators that could charge the bus fleet. So again, burning fossil fuels to charge the electric buses, not ideal, but it keeps the buses on the road in that emergency condition. And Long Beach is doing that, and I think we can look to what Long Beach is doing at their facility as an example. And frankly, I think it would be a big missed opportunity if we didn't put large-scale BESS at the Glendale Public Works Yard for those buses. So I hope we look into that and have the consultants look into that.
We've been having conversation with Public Works about just that, to minimize the inrush of electric use when you're charging batteries and to have this backup source. So they are looking into putting a BESS in that area.
Yeah. Yeah, and then, in general, Grayson in the past has been our backup. That's been our Honda generator in the garage. And so the 3 units, the battery, that'll give us 4 hours, 53 megawatts of the new gas generation. Hopefully the gas lines would be intact. And I believe that's what saved us in '94 during the earthquake, right?
That's correct. Our units were all started after the Northridge earthquake, and we were the first city back because of Grayson. And most of the units were down. We got them back up and running, and we were the first city back in power.
But if we had a major event again, because of the amount of electricity now being required and the vehicles being electric too, wouldn't you want to save Grayson for the emergency vehicles and such and have more rolling out blackouts or total blackouts of the residences and other areas of the city?
That's correct. I mean, we chose in 2018 not to provide the city fully with local generation. The original repower was 262 megawatts plus the extra 50, which was going to give us a 99% ability to self-supply. And the decision to council was not to do that. And we're down to 53 or 58 megawatts of thermal generation. So in the event that that happens and outside resources are not able to come into the city, there will be rolling blackouts, anything excess of 53 megawatts.
So have you updated your emergency plan to deal with this and this increased electrical demand for the city? Has that been updated?
It has not been updated yet. It's in the process of being updated. And if I may, I think I misspoke when I said that we have a 300 megawatt battery. We have a 75 megawatt, 300 megawatt hour battery. I was a little lax in saying hour, sorry.
Other questions?
When you were mentioning that adding an EV charger is like another home, you're talking about demand, you're not talking about overall usage, is that correct?
Well, again, it depends. I personally like the bigger cars, so a Lightning from Ford, a Rivian, they have a 120 megawatt hour, 120 kilowatt hour battery. To get 120 kilowatts out of 11, let's say the biggest level 2 charger, you need 10 hours if you were driving a long distance. But Commissioner Fay is right. If you drive short distances, then you don't have to plug it in. But if you've driven a lot, then you have to plug it in for 10 hours to charge it fully. It depends, could be 7 hours, but still that's substantial because that's 11 kilowatts for 8 hours if you need it to charge it up to that level. And I've had friends who, husband and wife, work. Why? Because they live in either Glendale, Burbank, Pasadena, LA. 2 incomes. They both want to do what's right for the environment, so they bought 2 electric cars, but they both go to work every day. So when they come home, they do their errands. They come home, they have to plug in both cars. And so I've had them jokingly say, Dan, I just doubled my load. I'm sorry. But what'd you do? My wife bought a second Tesla, and we put a second EV charger in, and they charge it both at the same time because they leave and do errands at the same time. So it just depends. But Commissioner Fay is right. You don't have to plug them in at the same time. If you could stagger them and you charge them enough to get you to work and back and do your errands, you're fine. But the batteries are getting bigger in the cars. I mean, that's reality.
I understand what you say about the big vehicles having the big batteries, but I don't want people to think that if I have an EV charger, I'm going to double my electric bill. I mean, I've had 3 electric cars, and it's a negligible increase in my electric bill, and I've had times where I have driven a lot, but okay. On the solar, you said that in 2024 you wanted to get the project started so you could get the 30% tax credit. Is that the requirement? You just need to get them started. You don't need to get them completed.
No, that's right. If you'd start them by 2024, that was one of the requirements so that you could apply.
Okay.
Yeah.
What's the definition of started? Breaking ground or just studying?
I'll have to ask our expert, Brian. But I believe, you have to make, awarded, get it started, design. I think, I don't know if they're very strict on that, but if you can show that you've made some progress to it. But, you can't just wait till the end of the year and say, I just started this. But our plan is to come to the commission, come to the city council before the end of the year, award it, and get them started. So we'll be well ahead of the curve. Hopefully we'll start it even this year. And then some may be completed. Some of the rooftop may be completed by 2024. There's 6 projects, so different various sizes.
I wanted to just react to one thing you said about electrifying a home and vehicles and the bigger panel and the impact on the grid. I think that oversimplifies it a little bit. I've done all those things at my house, and I haven't blown any transformers or anything.
Oh, no.
And I can cook dinner and charge my cars. It all works just fine. If everyone on the block did that, maybe there would be an issue, right? So we want to plan and get ahead of that as a utility. I think one way we could also mitigate that, short of building more poles and bigger wires, is being smarter about all this. And if that customer came with their permit application and said, I want to do A, B, and C, we could require them to put in a smart panel. And this technology is pretty well established. It gives circuit level control and would even help in those emergency situations where if we had lost access to outside power, imagine if we had citywide control to throttle customers' energy usage and say, we're going to keep your cooking circuits on and your air conditioning circuits on, but we're going to turn off your electric car circuits, or we're going to turn off your TV circuits or whatever, right?
Sure.
That would give us a lot more granular control over shutting off the feeder to this neighborhood for an hour, or the feeder to that neighborhood. That's kind of a crude approach, right? So I hope we're looking at, those kind of smart technology solutions to deal with our distribution infrastructure constraints. Because I don't think we can just build our way out of this with more wires and more capacity.
Yeah. My concern was that when, for example, developers and homeowners come, when they pay for a 400 amp panel, that's what they expect. And so we have to deliver that. Now, demand response, is there programs? Yeah, that's the programs we're looking at, where you get some type of incentive if you turned on your thermostat or if you turn off your EV charger. So that will be built in. With that, we can manage the load better. Of course, we're looking at that. But my concern was that when they come in, a developer pays for an upgrade. They're asking for that upgrade for the full intent. So I have to provide what they've paid for.
Sure.
It also includes upgrading the infrastructure back to the utility.
We might want to just think about being a little bit more nimble and say, okay, if you want 100% access to this level of power, it'll cost you $100 million. But if you just want 98% reliability, it only costs you $10 million. And I think there are probably some developers who would take that gamble and then use software systems to manage the load within their properties so that they didn't hit that demand charge. And I think if we set up the terms of that engagement, we'll get a lot of uptake from developers, because it's going to get more and more expensive to build more and more capacity, right? We're running out of pole space, we're running out of places to put underground vaults and all of that. So I think we want to think about other ways to help customers and developers, meet their commitments to their residents while not overstressing the grid.
Okay. Yeah. No. Good point. I agree that. Excellent point. Yeah. One of the things that, as a utility, what we deal with, it's just not. Let's say that because of electrification, the load doubles. It's not unforeseeable that may happen, but it's not just load doubling. It's also replacing aging infrastructure. So I have an aging infrastructure that I have to replace. On top, I have to double the size. That's the dilemma I have. Why? Because it has to be reliable. The wires that are there, as infrastructure ages, it has to be replaced. But also now, where there was one feeder in the area and we realize we need a second feeder, I have to add an extra feeder. So it's doubling the size of the system, but also replacing aging infrastructure. It's a tough thing. And I agree, there's software solutions where you can manage the load, and we would implement those. Because why? We can pass the incentives on to the customer, and that lessens our ability to need generation. So very true, there's solutions.
Yeah, probably needs an all of the above approach to deal with this over the next couple
thank
decades.
You're absolutely right.
Just one quick question. You may know the answer to this, Commissioner Fay. Are there currently utilities that do have that ability to manage at the circuit level at their end users?
Yeah, I'm not sure of specific examples, but I know I've seen some examples at trade shows that the company Span is the one that comes to mind, and I think they do have some utility partnerships.
I mean, I could see where, within a business, commercial property where they're trying to manage it from behind the meter type of a thing. I'm a little concerned on sort of the liability side, that if you have so the demand management now is a voluntary thing. People make their choice of what they shut down. If we're making that choice for them and suddenly they go and say, I couldn't get to the emergency room because you shut down the charging of my car, and therefore, I have a wrongful death lawsuit on your hands. That's a very different kind of thing when we're starting to take proactive decisions versus each individual volunteering to come onto a thing and then making voluntary choices of what they shut down. So it feels like that may be unchartered, some legal ground that we'd have to take a look at. But I'm fascinated if there is actually precedent that's out there, then somebody else has charted this, and we should benefit from, the fact that they went into uncharted territory and they've got the scrape bottoms of shoals that they've already come across.
Yeah, I I think we're probably going to have to dig a little deeper over the next couple of decades as climate change gets worse, and so voluntary action may not be enough. In the example you cited, I think we would probably use the vehicle charging smart charger and say, we don't want to cut off charging unless your car has at least 50 miles of range, in the tank, so that you could get somewhere like that. And the cars are smart enough to do that. A really easy kind of no impact example would be a heat pump water heater. If you have an electric water heater, the water in that tank will stay hot for 4 hours without any impact. So you could shut off the power there, and then you could use that power for other things. So there's kind of every flavor in between.
Wait till you have teenagers.
Anything else?
Yeah, thank you very much.
Thank you. Next item, please.
Next item is 4C, renewal portfolio update.
Yeah, good evening, President Jasmine and members of the Commission. I'm Chi Valdez, Integrated Resource Planning Administrator for Glendale Water and Power. So today we're going to provide you the RPS updates. So basically the California RPS program was established back in 2002 by SB 1078 with the initial requirement that 20% of electricity should be served by renewable resources by 2017. So this program was accelerated in 2015 with SB 100, which mandated a 50% RPS by 2030. And that includes 65% of the RPS procurement to be derived from long-term contracts of 10 years or more. In 2018, the SB 100 was signed into law, which again increased the RPS from 50% by 2030 to 60%, with a plan to have 100% zero carbon by 2045. And then recently, SB 1020 was passed, which put the state on a path of achieving 90% zero carbon by 2035, and 95% by 2040. And in addition to that one, we do have the Glendale goal of 100% by 2035. So here's our power content label for 2022. So last year, we actually reached 35.2% of eligible renewable resources. That is, like about 59.9% clean energy supplied to GWP customers if we include large hydroelectric and nuclear. We were a little bit short compared to that of California mix in 2022. That is because the planned commercial operation for the Star Peak project was delayed. If it's not for the delay, we've actually forecasted to be at 38% renewable for that one. There's a couple of things I do want to highlight here. The first one is the solar percentage. That was last year was actually the first time that we would see solar in our portfolio. That is part of the deliverable from the townsite solar project, which we referred to before as the Skylar project. And as a result, you could see that there's also some reduction in our biomass and bio-waste, because at that time, that project or that contract was actually delivering a lot from biomass project. So this chart illustrates a renewable and zero carbon position in reference to the California RPS annual targets and milestones. So as you can see here, GWP has a long history of supporting renewable and clean energy. Actually, back from Hoover days in 1937 to the more recent long-term investments in wind, geothermal, hydropower, nuclear, solar, and biogas projects. So on this chart, you can see that the red ones are actually our existing projects, and we do have some projects here that we are currently under negotiation. That's the green bar portion. And, sorry, the zero carbon are, like those in purple bars. So the line that you can see in here is basically the targets for RPS. We are on track for the 2030, means that 60% RPS by 2030. But as you can see, like with the increase in the regulation, that we are still like falling short for renewable resources. But we are committed to continue and expand this progress in a cost-effective manner. Yeah, so despite of the progress that we've made so far in transitioning to clean energy options, we still have a lot of work to do to meet our goals. So this slide captures some of the challenges and concerns that we must overcome. So the first one, as everyone knows already, are the project delays. This is due to the disruption in the global supply chain. So for example, our Eland Solar project, we actually planned or we forecasted that one to be online this year, but until now we haven't received a single panel for that project. The battery is already there. They already set up, except for the panels. It's not coming in yet. So there's still a delay on that one. The same thing with the Star Peak project. It was delayed for a year. Before we were able to get, like like some deliveries from that one. And the next one is the energy shortfalls from our renewable resources. Yeah, like especially with the Star Peak project, it came online, but it wasn't producing as it was supposed to produce. So like that project, they're delivering 70% less. I mean, they're delivering only 70% of their guaranteed generation. Same thing with the Whitegrass project. It's delivering about like 15% less from that project. So the next one in here is the fractional or the unspecified source energy deliveries. So I'm referring to the brown component of the delivery due to rounding of schedules to a full megawatt. This is a system-wide e-tagging limitation. That means that some of the energy delivered from these renewable projects could have carbon component to it. The next one is, of course, like the escalating renewable energy costs due to the fluctuation in materials, shipping, labor, and interest rates, and of course, coupled with the increased demand in renewable resources. So transmission capacity limitation. So limited transmission means limited ability to import renewable resources and potential of stranding assets due to transmission derates or outages. The load variability, like as discussed earlier, it poses a challenge, especially when you're relying heavily on intermittent resources. EV charging, building electrification load can be variable, leading to fluctuations in electricity demand. So matching our supply and demand becomes more complex as these load patterns change. And then lastly here, there's actually a unique situation that is currently unfolding in our energy market. The cost of the renewable energy credits has significantly risen that it exceeds now the penalty fee for non-compliance. So meaning this surge in REC prices means it's more costly to comply than to than to just, like pay for the penalty for noncompliance. It is distorting the market dynamics, especially for this compliance period, which ends in 2024. There's not a lot of renewable resources out there in the open market to make up for the shortfalls from the delays in these projects. Just to give you an idea, the penalty cost is $50 per short rack, but the prices right now, it's hitting like $75 per rack. So to ensure that our city remains on track in achieving our renewable energy targets, a comprehensive approach is necessary. And our approach or strategy mitigation involves, first one here is market intelligence, like to continuously monitor and analyze the renewable energy market. So this includes tracking trends in renewable energy costs, fluctuations in REC prices, and changes in the regulatory policies to help us make informed decisions about our RPS targets and adjust them as needed to align with market realities. The next one is collaboration efforts among other utilities to share knowledge and jointly work towards RPS compliance. And we also need to improve our contract terms to address those operational issues, such as those brown energy component. Of course, like incentivizing our distributed energy resources, such as demand response, energy efficiency, those rooftop solar and storage for load shifting and peak reduction. And as for load forecasting, we need to incorporate now those solar forecasts as well as those EV charging patterns to minimize those load uncertainties. For advancement in technology, like looking into those green hydrogen, long-term storage, and carbon capture technologies that can reduce the impact of the intermittency of solar and wind, and provide a more stable supply of clean energy. And lastly, like to conduct an in-depth feasibility studies for renewable energy projects, including those within our city limits, to prioritize those projects with highest potential for reliability, cost effectiveness, and impact to our RPS compliance. And the last slide here, I just want to go over some of the projects that we're working on. So the first one is the 2024 Integrated Resource Plan. We're currently, at this moment, we're currently modeling 6 scenarios. So 3 from GWP, and then we're able to come up, and the STAG group was able to come up with additional 3 scenarios to be modeled. The plan is to come to the commission on November 6th to present to present the results of this one, or to present the draft of the IRP, and go to City Council by December 5th for adoption of the IRP. And the deadline for submission to the CEC is January 1st for that one. So the next project in here is renegotiation of the Star Peak and Whitegrass geothermal projects. So as I mentioned, this project is not there's shortfalls, like in the deliveries of this project. We are going to City Council on October 10th to present the amendment, for the approval of the amendment to address those energy shortfall, brown energy deliveries, the delay damages from the Star Peak project, as well as the test and startup energy and system credit. And as a condition for this one, the developer will pay Glendale a lump sum of approximately $2.2 million for all this, delays that the project has caused. For IPP, it's on track for 2025 COD. By 2025, that would be converted into natural gas. And hopefully by 2027, when all the participants except Glendale, Burbank, and LA, we will be able to get the extra access to the Southern Transmission System, about like 72 megawatts for that one, additional. We're also doing a monthly collaboration, Glendale and Burbank with LA, and we discuss opportunities. How do we get there? We're all in the same situation right now where we're having issues, like getting renewable resources, how to bring it into the system. So those are the things that we're discussing. There's no concrete solutions yet, but we are continuously, collaborating with them. And Dan already went over the city-owned solar projects as well as the Shoal Canyon project. We are really looking forward for the Shoal to come online in preparation for summer of 2025. Because at that point, we're still doing the Grayson Repower. So every bit, counts for us. And then, of course, Grayson Repower, the plan is to have it by summer of 2026. And lastly, in here, we're looking into a small local commercial PV solar project. We will buy from them. Their solar generation is through a PPA, not a feed-in tariff. And that concludes my presentation. So if you have any question, I'm here to answer those.
So you mentioned a $2.2 million credit because the project developer missed their commitments. Is that right?
Yeah, that is correct. So we were collecting liquidated damages for delays, and it actually got to the point where the development security, we maxed it all out, and there were some issues in there, but all in all, together with the delay damages, those shortfalls, they miscalculated things and things like that one, so it came up to 2.2 million.
And has that money already been spent? Is this new money coming into the department? Do we have any restrictions on how we spend that?
It's new money coming in, but of course, we purchase replacement power, right, for this one.
So has the 2.2 million already been spent in essence, or is there any net new money there?
There's not new money, it goes into power purchase.
Yeah.
Gotcha. So essentially they're reimbursing us for the costs we incurred because of the developer's failure to meet their commitments?
Correct.
Correct.
Rats, I thought we found some free gold in the gutter there, but no free lunch. On your slide, you mentioned DERs and consumer behavior as a mitigation activity. Could you describe a little bit more about what we're doing there or what is in the IRP in that department?
Yeah, that is correct. So, so for the DERs, there's an ongoing study right now to develop this study. It's a feasibility study looking into this 10%, having 10% rooftop solar and the 100 megawatts of DER. So we're all, looking forward to that one and how we could incorporate it into our, future IRPs.
So we kind of included some assumption that something good will come out of that study, but we don't know what that will be yet until the study is complete. Is that the idea?
That is correct, but for the IRP, we made some assumptions based on historical performance.
Okay, great. When do we think we get the results of that DER study?
The contract hasn't been signed, it's just been approved by council, and we're negotiating the contract right now.
Okay, great. And could you talk a little bit more about the local commercial solar PPA? Or is that kind of a forthcoming project that?
Yes, it is.
For those that not sure what a PPA is, it's a power purchase agreement. We're trying to do something a little bit different where there's not going to be a feed-in tariff because feed-in tariffs actually change all the time. So it's not desirable for developers to get into a feed-in tariff with Glendale because energy prices could be 150 one month and it could be 30 the next month. So we're looking at a power purchase agreement, and with that power purchase agreement, they can be guaranteed price, but it also would require them to perform. So there would be guarantees and liquidated damages. We're looking at a pilot program with this one company, and once we get a little bit comfortable with it, we'll be able to present that to anybody else who would like to participate.
So that would be kind of an open call for projects, say, we'll pay you this much if you can produce this much solar panels.
That's correct.
Okay, great. I think that's a great approach. I think a lot of what I've heard since I've been here is the department's attempt to kind of build its own way out of our problems, but I think a lot of what we can do is leverage the private sector. If we set up the conditions, let them invest, and we kind of get double benefits. So I think that's really encouraging. Thank you.
I'm looking at the California RPS program, and I see our Glendale goal, 100% clean energy by 2035. That's basically 11 years and 3 months from now. I'm just wondering if anybody would hazard a guess as to what our energy resources will look like once we meet those goals. Would you hazard a guess, Mort?
I'm a little gun shy if I were to actually guess, because then somebody would take a snippet out of this meeting and tell me that I guaranteed this. But we're doing the best that we can. I don't know if we can get there in today's technology, but we're looking at more aggressive technologies, maybe even looking at small modular nuclear reactors to assist us, not to have one in Glendale, but to have it in Idaho, that would allow us the capability of being able to have offtake of that facility. I think we have to be very aggressive in what our load is going to look like. Right now, the peak load is between 4 and 9, but I think as you start getting more and more EVs and you electrify buildings, I think that load is going to go from 9 o'clock. I think it might even go till 12 o'clock. So your peak will go out further. And the price comparison between off-peak, which is everybody's saying, just move your electric load to off-peak hours, that'll be a thing of the past. I think the midnight hours will be more expensive than the daylight hours because we're taking thermal generation offline and we're relying more on solar. So I think we have to keep in tune with what's going on 10 years from now. And that's what my power management group is trying to do in conjunction with coordinating with SCAPA. I think it's a great tool for APPA, CMUA, and SCAPA to figure out where we're going to be in that duration of time, because really, we're not looking at next week. We're looking at 10 years from now and how we're going to meet that. So I couldn't give you a solid answer as to what the portfolio will look like, although we're being very aggressive, but that supply chain and COVID actually retarded all, if not all, most of the projects. So Glendale's not the only utility that's having a problem finding assets. I think everybody's having a hard time finding assets, and then the prices are starting to skyrocket. So, like you said, which is the solar project we're with Los Angeles? I'm drawing a blank. I'm not sure. Elon. Elon was the cheapest solar. Well, the cheapest solar hasn't been producing any solar for a while, so we'll see what happens. But I think as we start to develop more and more renewables up in the IPP area, where it's in Utah, I think that's a great opportunity for renewables, and that's just in the infant stage right now.
Okay. Thank you.
Our next item is for D, cost of service analysis.
Commission members, Dave Davis, Utility Finance Manager. I'll give a brief presentation on how we're going to finance Grayson and Shoal. And after mine, Tony Georges of New Gen will give a brief presentation on the cost of service analysis. As you well know, last fiscal year, City Council approved the Grayson Repower and the Shoal Canyon Biogas project. for a total cost of for approximately $600 million. In this fiscal year, electric utility is expected to come up with $242 million for these contracts on Grayson and Shoal. Construction has already started on these projects, so these are firm commitments. And the following year, another $256 million, and the remainder in the last fiscal year of 25-26. And to pay for these, we plan on issuing bonds. This is how we're going to finance these projects. And so we looked at 5 different scenarios. Our goal was to find a scenario that, you know, gave us enough money to fund the projects and also lessen the impact on rates for the ratepayer. So as you can see from these 5 scenarios, the 5th scenario, the projected rate increase, these are average rate increases across the rate classes. We have not calculated the increases for each rate class yet. That's in the process. But scenario 5, you can see 14.8% average the first year, 11.3 and 11.3 the following 2 years. We came up, that was the best scenario for these projects. You can see the different rate increases the first year, and we thought those were unacceptable. We thought the scenario 5 was the best option. Now I want to point out on the right column, the maximum debt service, $42.4 million. When you issue bonds, you have debt covenants. And in order to sell the bonds, or in order for people to buy the bonds, they want to see these covenants in your bond documents. So our debt service ratio, which is the principal and interest on the bonds, we have to meet is 110% of the maximum debt coverage ratio. So for that $42.4 million, the maximum will be approximately $46.6 million. And that number will come down every year as we pay the principal on the bonds. But that's a lot of money, and that's why, you know, we chose scenario 5, because that'll lessen the revenue we need to pay the bonds. So in summary, we chose scenario 5, the lowest first-year bond issue equals the lowest first-year rate increase. And the rate increase will meet the minimum debt coverage ratio of 1.1 times. Our actual goal on that debt coverage ratio is between 1.5 and 2 times. The rate increase will provide the necessary cash and cash reserves going forward. So that's the end of my presentation. If you don't have any questions, Tony is here to go on with the cost of service.
We have questions.
The main question I have is on the second slide, the summary. It says the total cost of the projects is $600 million, but the recommendation you outlined is to only issue $500 million of bonds. So where's the other $100 million come from?
Currently at this time, we have approximately $155 million in cash reserves, unrestricted cash reserves.
And does that mean we're not fully paying the costs of these projects? We're
No, we
essentially
will, but,
paying for them with surplus accrued in previous years?
Yeah, that's correct. And then as the rates are increased, we'll have revenue and additional reserves going forward.
So this is just kind of our float or our working capital as a business, so we don't need to go raise the entire project cost?
That's correct.
Okay, thank you.
Yeah, and originally we wanted to issue $600 million, but you see from the numbers that wasn't, possible.
Right, yeah, and it looks like we're choosing not the cheapest overall option because we want to mitigate the first year rate spike as a result of the financing. Is that right?
That's correct.
Okay.
So if I'm understanding this, first year increase will be 14.8%, subsequent will be 11.3%. of the prior year or of the current, is it compounding?
Yes, sir.
Okay. And what interest rate on bonds are we paying on these bonds, or are we estimating here?
Yeah, when we ran the scenario, the rate was 4.25%.
And is that holding, or is that going up in the interest rates at this point?
Well, we're trying to go out to the market, hopefully sometime in December or January. You know, the Fed had been talking about increasing rates, and that's one reason, you know, we don't want to delay too long.
Right. Yeah, so the second thing is, and maybe you can educate me, historically in the past, what kind of interest rate would we have been able to get on bonds?
We've issued 2 water bonds and about 3 electric bonds in the past, and all the rates have always been between like 410 and 450 in the past. So historically, in the 4s
I
is,
see.
you know.
So like in 10 years, there's no hope of redoing these bonds at a much lower interest rate or anything?
Yes, there is. When we issue bonds, we can't refinance them for 10 years, but after 10 years, they're callable. And if rates are lower, like when we go out for bonds this time, we're going to refund 2 other electric bonds and then save approximately $10 million on those.
Okay. All right, that's it for me. Thank you.
Peters?
So I think your callable bonds probably with a 10-year minimum, but you have a prepayment penalty prior to that. So if the rates dropped enough, you could do the analysis and say it's still worth it, including the prepayment penalty, to go ahead and refinance inside of 10 years.
Yeah,
Just, there's a pre-negotiation, it's just after 10 years, you can go ahead and call without a penalty. Just saying, just for purposes of understanding that we can refinance at any time. It's just that they've put in a prepayment penalty in the first 10 years, but if interest rates dropped enough, I mean, I remember when we had prime at 21% in 1982. So, you know, things can change, but probably not overnight and not in 10 years. I guess one of the questions I was looking at, though, is because it compounds, why would you not think about option number 2? I was just doing the calculations here, and you're right that, so I just said, let's say that somebody is paying $100. And if we go with option 5 versus option 2, at the end of, you know, the first year, you're going to end up paying $119.8 versus $114.8, so $5 difference between the two. By the next year, the difference drops to only a $2.2 difference, because now you're putting the interest rate on a new amount, so it's 127.8 versus 130. But by year 3, you actually are inverted. And my sense is that there's going to be a whole bunch of other out years that will happen, and it feels like there's a little bit, you know, I could see if it was like this is going to be long enough over 5 or 7 years that you would be ahead, but your net present value isn't going to right itself within the first 2 years enough to really make it, and you're going to end up paying a lot more. So I guess what I'm suggesting is that option number 5 actually costs in present value dollars probably more to the ratepayer than option number 2 would.
Well, option 5, the compounding was approximately 42% over the 3 years. And scenario 2 was like 41%. So slightly lower, but, you know, that first year rate increase, you know, was important for us to keep as low as possible.
So that sounds like a policy decision, or a very subjective decision, that we would rather reduce essentially the political shock to people of getting a big bill, even though they're going to be paying more over the long term, right? That's what we've decided, or what you're recommending.
Correct.
So, you know, this body could recommend, or the city council might decide, no, we want to reduce our overall costs, even at the trade-off of having a higher first-time bill shock. those are policy decisions that we could make either way.
Correct.
Is there any kind of a cap that we have or limitation with regard to, I know, for instance, like with property taxes, if you're doing sort of general obligation bonds, depend upon what kind of entity you have a cap on X amount per $100,000 worth of assessed value or anything like that. Is there any similar kind of cap in terms of a limit to what rates could be done or a limit to the total amount of debt that you can take on?
Not to my knowledge.
Thank you. Those were the only questions. Thank you.
Yeah. Okay, so these rate increases are only for the bonds, and then on top of that, there will be more increase for O&M and everything else.
No, they've been included in
Been
here.
included? Okay.
And these are average rate increases. I think that Tony Georges from NewGen, his presentation would explain to you the process of the cost of service study. So unless you have questions for Dave, I think that if we went to Tony's presentation, it might give you a little bit more insight. I know it's going to give you a lot more questions, so it might be a good idea to let him explain the process of COSA.
Couple more questions before we move on. So the debt coverage will be at 1.1. Does Glendale have a rating? What's the rating for Glendale?
Yeah, bond rating is AA.
Double A? Okay. If you move that debt coverage up to 1.5, which is what you're usually looking for, would that rating increase and the interest rate decrease?
In the future, we can't do it right now because of the size of the projects we're doing. But like, for example, we just got upgraded on the water side, our water bonds. So it is possible down the line, if we have sufficient cash reserves and net income, that when we meet with the rating agencies every year, we go for a review. It is possible to get upgraded.
Okay. Okay.
So you mentioned that cash reserves, but we're going to be spending down about $100 million of our cash reserves
Correct.
through these projects. So we're kind of moving backwards if the goal is to improve our bond rating.
Well, Tony will tell you that 3 or 4 years from now, we'll get our cash reserves back up.
Okay.
And the debt service ratio. Both will go up, and Tony will explain to you days cash on hand and the debt service ratio, what will happen in the event that we do proceed with this average rate increase. And we were only showing 3 years of increase. Yes, it's a substantial increase, but this is a 5-year COSA, so year 4 and 5 are projected to be 0. So no one's going to care about that today, but it is a 5-year COSA.
Okay. Thank you.
Thank you. As David mentioned, my name is Tony Georges with NewGen Strategies and Solutions. We performed the COSA. It is a 5-year COSA, and we'll show you the process by which we came to these numbers. We did run all those scenarios that David showed you with the different bond issuances and the different phases or tranches. We'll show you the results of that over a 5-year period as well. Just to briefly review what we'll be looking at today, we'll primarily be focused on item 2 there, the financial forecast. I'll give you an overview of the overall COSA process. There are 5 key steps to that process, but the majority of our time today will be focused on the financial forecast and what that looks like over the 5 years. Things like the coverage ratio, how that's fluctuating and moving. Same thing with cash reserves. And then the final few slides will be focused on the actual results in the COSA, looking at what we call a revenue requirement, which I'll explain in more detail. It's more of a snapshot rather than the 5 years. It's an average of the 5 years. We take that snapshot and then slice and dice it or look at it through different lenses to give us different insights on the overall cost of the utility. And then finally, we'll wrap up with translating those average system bill impacts to what they are by class from the results of the COSA. I will preface all this by saying what you'll see in the COSA results at the very end are not rate recommendations, they're just the snapshot. So we'll work towards those numbers over time. This is an overall COSA process, very standard for any municipal or regulated utility. 5 key steps. Like I said, we'll be focusing on number 1 for the majority of the presentation today. That's the revenue requirement. These are the total costs to provide service to all customers. Steps 2, 3, and 4 are really embedded in the COSA, with step 4 ending with the costs allocated to the customer classes. So translating that total impact of 14.8% to what it is by class for residential, small commercial, industrial, and so on. Step 5, which is to be completed, which is currently underway, is designing the actual rates. So that would be the actual monthly base charges and the energy charges and demand charges that would be in the tariff for each of the customer classes. Just to look at the process and describe what we went through as far as the financial forecast and really optimizing that. You did mention, looking at the different debt tranches, and while the MPV of one may be better than the other, we ended up looking at the scenario 5, looking at it spread out over 3 years or 3 tranches. This is where we did that analysis, and we looked at that and optimizing. On this left side, you can kind of see this pie chart. We look at the levers of debt that we can issue over time and those impacts under some assumptions of the interest rates. We look at rate changes that we can implement and cash reserves. So we monitor all those things each year and dynamically over time to try to optimize them to spread out rate impacts for the customers and optimize use of debt and minimize the impact on those rates, and also managing cash reserves and meeting those financial metrics, which are here on the right side of the slide. When we perform these studies and looking at optimizing the financial forecast over time, whether it's 5 or 10 or 20 years, we're really looking at 2 key metrics for the most part. That is the debt service coverage ratio. You can think of that as the net revenues. So the total revenue that is received by GWP less the direct O&M expenses are your net revenues. That number divided by your annual debt service is what gives us that ratio. And so we're targeting 1.1, so 110% of the debt service on an annual basis is a minimum, bare minimum, required in the bond covenants. Eventually, we're targeting to get it back up to a 2.0, which has been a more stable target, standard target for utilities. GWP has been at 2.0 or well above for many, many years. So that gets us much better position, a much better footing from a cash position for the utility. And then days cash on hand, you'll see it may be abbreviated in here as DCOH. That is your working capital, the amount of cash in your savings account, so to speak, for the utility. And we'll see that translated into number of days. And so we have a target of 300 days for the utility. And those 2 targets are what we manage and optimize around. So I think it's really important to touch on some of the differences from the previous COSA that we ran to what's happening now. Obviously, COVID's a big hit, but there are a bunch of changes that have impacted these numbers and continue to influence them. The load forecast was a critical one. As we updated that from the 2021 COSA, it had a significant impact. We'll show you quantitatively how that impacted the results here on the next slide. Changing the generation technology and the strategy and the debt structure, all those things were evolving over time. We looked at all those and continued to analyze them, evaluate them to where we ended up today. The financing structure, as you saw on David's slide, went through several iterations on that and scenarios. Did also want to highlight, which you're hopefully very familiar with, there are 3 what we call pass-through or adjustment charges for the utility, and this is extremely common and a standard industry practice for almost all electric utilities. But you have the regulatory adjustment charge, the energy cost adjustment charge, and then the revenue decoupling charge. Those are rates that are adjusted on a monthly, annual basis to adjust for things that, to adjust for actual costs or actual load conditions that are different than what was projected in the original COSA. So as power supply costs change from what was expected, or as load changes from what was expected, these mechanisms are used to fully recover costs to make GWP whole on the cost side from the conditions and from the actual conditions incurred and the costs incurred. We integrate those adjustment charges as they stand right now into what we call the base rates. So there's the base rates, which are a key piece, which are the rates that are in the tariff. So if you looked up the GWP ordinance and the rates in the tariff, that's what you'd see as base rates. Here's our customer charge, energy charge, and demand charge. And these adjustment charges are on top of that and fluctuate or adjust based upon the actual costs. As we absorb those adjustment charges into the COSA, which is the practice of GWP with each COSA, those are set to zero. Those current costs or those rates are essentially embedded into the tariff or base rates. That is the equivalent of a almost 22% rate increase. I do want to mention that while that shows as a 22% rate increase or 21.7, but actually your bill doesn't change. It just changes from how it's being collected. So it moves out of adjustment charge into a base charge, and your bill stays at the same level. It's just the mechanisms that are used. This slide just further discusses those base rates and cost adjustments. Really, the key point here is we're zeroing out all those three adjustment charges, and those will be embedded into the base rates as we look going forward. The numbers that you see and have seen from David regarding the 3 years of increases are on top of what have already been absorbed, so on top of that 22%. So I would think of these changes as your bill change, not necessarily a quote-unquote rate change. I know it's a nuanced element, but I think it's better to think of it as a total bill change.
Just while you're on that point, if somebody was to complain about a 40% increase in bills or in the base rate, that would be disingenuous, right? Because they're conflating the conversion of the adjustment factors with the base rate change.
Correct, because in actuality, for example, if there were no bill increases recommended, you would still have a 22% rate increase, but your bill would still have $0 change. So it's just moving it into the base rate, the bill stays the same. So, to the numbers. These are some of the results that can highlight some of the differences that we've seen in the past couple of years in analyzing the COSA and how they have impacted the results that you have seen and will see. So looking at the first table here, you'll see the first row being the 2021 COSA power supply forecast. So these are the power supply costs. You can see in 2022, expect to be 121 million, 122 million, 131 million, and so on throughout 2028. The next row, you can see the 2023 COSA, or the current recommendations and expectations and assumptions for the power supply forecast. You can see they've grown significantly since the last time. Some of that has been realized in those adjustment charges that you're seeing, but they're also forecasted to be higher in the future than currently, or than were projected in the 2021 COSA. You can see those numbers ranging from 33 to 50, 45, 20% in the out years. So substantial increases in the power supply forecast numbers and expected costs incurred for power supply costs. And then finally, the second table here, the lower table, similar table, but showing you how the change in load has impacted the COSA results. So the first row here is the 2021 COSA load forecast, and the load is just the total megawatt hour, so total energy consumption over the year. And then the second row being the 2023 assumptions that we now have, or forecasts that we now have for load, and the final row obviously being the difference. How I would interpret these, or recommend you interpret them, is when you see a decrease in the load forecast, which you see in 2022, 23, 24, 25, those decreases, the load forecast now is about 3 to almost 5% lower than it was in the prior COSA. That essentially or generally equates to about a 3 to 5% rate increase or bill increase. If we're selling fewer kilowatt hours or expecting to sell fewer megawatt hours, obviously we have to have a lot of the same costs to recover, thus there's upward pressure on those bills and on those rates. These are the results of our financial forecast using those 3 tranches of debt issued in 24, 25, 26. Those are fiscal years, $166 million each. The top row of this table here shows you the revenues generated after these bill increases are implemented. These are the revenues by year for the utility, for the electric utility. The revenue requirement are the total costs that GWP must recover to run and operate, provide service for the electric utility to all customers. So think of that as just the total cost we must pay for. The third row is what we call an annual over and under collection. So that's really impacting our cash flow from year to year. And then you can see those rate increases, or bill increases that were needed to meet the financial metrics. And then days cash on hand, DCOH, and DSCR is debt service coverage ratio. Again, those 2 key metrics, I would think of them as 2 key constraints as we must meet to maintain the credit rating for GWP, and meet the bond covenants. You can see here that in year one, the debt service coverage ratio is exactly at 1.1 under the current projections and under the revenues and the rate or the bill impact that we've analyzed. We get or maintain 300 days cash on hand there, actually at 308. These two subsequent rows, income to meet depreciation and transfer over under on an annual basis, and then bond net income test. These are two additional tests that are run just monitoring financial health. You can see those do not meet the test in 24, but in 25, 26, we do meet those tests and maintain, go in the black per se, as we continue in the future. What I draw your attention to in this is we do need a significant rate increase or bill increase in year one to meet that 1.1 coverage ratio. So that's at the bare minimum to meet that coverage ratio. In years 2, 3, and 4, and so on, you can see in 2025, 26, 27, we're maintaining at or above 2.0, and that would be a target that I would strongly recommend, and it is a target of GWP to maintain. That and the days cash on hand maintaining above 300 on an annual basis are two critical items that the rating agencies will evaluate in determining financial health and eventual rating, which does obviously impact the debt and the cost of debt for the utility. So this is transitioning from the financial forecast and what we're looking at over time, discrete years in a forecast, to what we call a test year revenue requirement. Essentially, that's just averaging the 5 years. So we're taking one snapshot and then we allocate it to the customer classes. That's, again, it's just a part of the regulated economic process of a COSA. The results that you see on a class-by-class basis are a one-time bill increase or one-time rate increase at time zero, basically. So if you add or compounded the 3 years of bill impacts that we're looking at right now, it's going to be a little bit different than the snapshot. That's just because the compounding effect and we're phasing things in over time. It's just a compounding element of it. It's not anything wrong, I guess, with the numbers is how I'd phrase it. And we'll show you that. So there's a couple interim steps that we get to before we get to the costs by class. And they're important just to identify what are the key drivers in or the overall cost or the overall revenue requirement of the utility. So you'll see a number here that's repeated multiple times is $306.8 million. That's the total test year revenue requirement to run GWP, the electric system. I would think of that as the average of the 5 years, so the average revenue requirement of the 5 years to run the electric utility. This first table shows what we call the functionalized revenue requirement. So there are 4 functions to the utility: production, transmission, distribution, and the customer function. The customer function, you can think of that as customer service, key account folks, your customer billing system, just things to interact with the customer. You can see this number is dominated by the production functionalized cost, almost $236 million of the 307 is related to production. The next highest one is distribution. These are fairly common for utilities, not only in California, but across the country. That's typically a mix, heavy into production, heavy into the production function. The second table is that same $307 million, but it's put into the 3 classifications within the COSA. Those classifications are customer-related, demand-related, and energy-related. This table and the associated graphic here on the right, the pie chart, are really important to understand the fixed versus variable nature of an electric utility. These numbers, again, are pretty common for California. On the pie chart here, the blue portion of the pie chart is 60% or $185 million of the 306. 60% of the cost of the electric utility are fixed. So you can think of that as no matter how much electricity is consumed, even if it was zero kilowatt hours, we take it to the very extreme, you still have $185 million of costs for the utility. They don't go away. They're always there. The other 40%, $121 million, is variable. You can think of that as variable purchases on the energy market or consumption of natural gas, the fuel to run the power plants. Those are variable. They do vary with how much electricity is consumed. So that is important, and it'll eventually cascade into how we design rates for the classes. We do want to, the best we can, align the rates, a fixed portion of a rate or a tariff, for example, the base monthly charge or demand charge, we consider those fixed. We typically want to align those as best we can with this pie chart by class. And that's another item that's actually reviewed by the rating agencies. That helps get the electric utility aligned with recovering the costs in the same way and sending the same pricing signals to customers. And so if we're using less electricity, we're not really harming or under-recovering fixed costs. And that's one of the issues where electric utilities have evolved over time and we've gotten better at. So as we use less energy, we're not harming that fixed cost recovery. So the final slide here is translating that $306 million into what it looks like by class. So there's a lot of information on the slide I want to slowly walk through. The y-axis here is what we call an average rate. You can think of that as I take my total bill and divide it by the total kilowatt hours that I've consumed. That gives me an average rate. So you can see that number varies from about 5 cents per kilowatt hour on the lower, or is actually all the way down to 0 cents per kilowatt hour, all the way up to 40 cents per kilowatt hour at the top of that y-axis. Across the x-axis, you'll see the 4 different customer classes for GWP. The yellow dotted line across the middle there is the average system cost of service result rate increase. So that would be the overall revenue requirement for GWP. The difference between that and its current revenues, shows a 33% bill increase necessary on a system-wide basis if everything were implemented right now, right at this time zero standpoint. Since we're phasing things in over 3 years, it's a little bit different than that 33%. Now, if we translate the system impact, we can look at each discrete class. The blue bars are the test year revenue requirement effective rate. So that's taking the overall COSA, that $307 million, $306 million, and looking at what each customer class's contribution to that should be based on the COSA. And then it compares that to the orange bar, which are the current rates or the current revenues at the rates that are currently implemented. And then that difference is in the yellow bubble there across the different classes. So you can see in residential, the COSA indicates that the costs to serve the residential customer class are 43% higher than the revenues currently recovered in the residential class. Very similar numbers for small business. Medium business and large business are slightly lower than the system average. They're at 20%, and large business being right close to the system average at 28%. This, again, is the COSA result, so this is a snapshot. These are not the rates that we are recommending in year 1, year 2. We would phase these in over time, just like we did the system average of 14.8, 11.3, 11.3. We would do something similar in these classes. The outcome of this is we would want to work towards these COSA results by class over time. We can do that over a 3-year period, a 5-year period. That's to be determined policy decision. And we started on that process to give some input to GWP on what that would look like as far as phasing them in.
Could you speak to whether or not these percentages include the 21% shift from adjustment factors to base?
This is on top. So again, think of it as the bill impact. So the 21.7% has been absorbed. So this 43% is on top of what the bill is per se right now. And I'll mention that the kind of the balance between above or below average as far as commercial and residential, this is fairly typical of cost service studies that we perform across the country and in California. So typically, commercial customer classes typically indicate a slightly less than an average increase. Residential, small commercial businesses usually indicate or result in a slightly larger than system average rate increase. So the trends that are shown here, well, maybe not the magnitude, but the trends are very, very similar across the country.
So I was always told that there's no dumb question, but I'm going to try to come up with a few. I'm trying to understand. So you said rates will go up, but your bill doesn't.
Only.
Help me explain that to my wife.
So yeah, it kind of sounds like an oxymoron. So let's separate these recommended bill increases or revenue increases for Grayson and Shoal and all the capital projects and this outcome. If there was no bill increase recommended, we would adjust the rates. So the rates have 2 pieces. There's the base rate, which is in the tariff, and then there are adjustments which fluctuate month to month, year to year, based upon actual costs for the utility and meeting the financial metrics. So if we take the snapshot as of right now, your base rates have been set that way since, I believe, 2019. They've been enacted or approved at that point in time. So, 4 years ago roughly, but those cost adjustments have changed every year. So when we do new COSA, we eliminate those cost adjustments and we bury them or embed them in the base rates. So the base rates would go up or absorb those cost adjustments, but your total bill would stay the same. It would just be which charge was changing to get to the same. Let's say if you're $100 or $200 a month average bill, you're still paying $200, but the rates that would get you there would be a little bit different.
Okay, got it. So, and if I understand it, what you're saying is that the base rate should be aligned to the fixed costs.
The base rates are aligned with the COSA, the projection.
Okay.
The fixed costs would inform, there's roughly 3 separate charges on your bill in very general illustrative terms. That would inform which of those charges we would change and by how much.
The other question I was sort of trying to noodle on is, so as you come up with these numbers, what kind of, are we talking constant dollars? Are you taking into consideration, what is your discount rate or escalation rate that you're assuming in all this?
We have escalated, depends on the account, but we do look at the chart of accounts in GWP's budget, which is quite lengthy. So we'll look at labor cost, what we would escalate labor costs as, what we'd escalated just generic inflation, what would capital dollars be escalated at, because those are typically escalating a little higher than a CPI type of escalator. So depending on the different accounts, we will escalate those and project and forecast them over time at nominal dollars in those years, not our current real dollars.
So the rate increases and what's needed for the revenue is based on, as the escalations baked into it?
Yes, and loads changing and a number of other conditions.
Because when I was just looking at slide 6, where you show that when we did the revenue requirements forecast in 2021 versus what we're doing today, and there's a major shift. I mean, I'm assuming a lot of that has to do with the fact that we went from kind of zero inflation to, to 6-7% inflation.
Supply chain constraints, things cost more, obviously, and that's just been exacerbated in the power supply market and in California.
But all the numbers that you're talking about now are based on now a new ratcheted up presumption of a 6%?
Correct. No, we're not. Well, it depends on the account. Well, I mean, CPI isn't 6%, so CPI is actually projected to come back down and has kind of normalized back around the 2 to 2.5 range per year. But other accounts are changing at different rates. So when we look at it long term, the CPI is expected to stabilize. When we look at capital and some of the others, we've used higher incremental forecast numbers there.
Okay, thank you.
Just follow-up question to Commissioner Peterson's, and I'm trying to put this in layman's term to understand it. Assuming the rate increase takes effect in January of 2024, I'm going to get my bill. If I get my bill and it says a dollar figure, I don't care about base rate, everything, just the dollar figure. That's the amount. I write a check and send it in. Let's say in January of 2023, I paid $100. I wrote a check for $100 and sent it to GWP. In January of 2024, what would my bill be if I use everything the same?
On a system average basis, we haven't translated and designed the rates for residential yet. On a average basis, it would be that 14.8% increase. So if you had a $100 bill per month,
$114.
Exactly. If everyone received the exact same bill increase.
Right. So again, just not to confuse the public who's watching this with the shifting and the cost adjustments and all that.
Yes.
14% is going to be the increase. Okay. Now, the other question I had is on slide 13. So we're looking at the income to meet the depreciation, the 1.1, and then in 2025, that's 2.3, and then 2.4, 2.07, and then 2.0. And in 2025, we're increasing by 11.3%. In 2026, we're increasing by 11.3%. Why are we overshooting on the DSCR to 2.35 as opposed to just 2.0 and maybe reduce the increase from 11% to a lower number? I'm wondering.
We could. What it would do is push increases then out into 27 and 28. So it's, think of it maybe a little bit as a teeter-totter. If we brought
I
them
see.
down,
So at the
they would
end, you're
start
trying to get it to 2.0 by the 5-year COSA
We wanted to
period.
maintain 2.0 throughout those, well, after the first year, maintain the 2.0. So we kind of grow a little bit and then we eat into it and you see the cash coming down slightly as well.
Right.
And so after that 5-year period, you'd be looking at another COSA to then project out those 5 years.
Right, so, okay, thank you. Those are my questions.
Just one quick comment remember when I was at GCC, we did an analysis of the average rate or price, what people were paying for electricity from GWP over the last 20-year period, and it was like a 3.5% annual growth rate, compounded growth rate. And so just in context, now we're talking about going from a 20-year average of about 3.6% or so on up to an instantaneous 14-something and then landing on a 11%. So that's quite a significant change relative to what we've been doing sort of over the last generation. So obviously, I think our city council is probably already thinking about this and what this means for messaging and so forth. But I'm sure that people will be looking at this. That's why I'm just putting it out there first so that we can start looking at it clear-eyed.
So the last COSA was in 2019, right?
It was completed, I believe, in 18 and implemented in 19. And it was a five-year plan that I think you just completed the last year of.
And so since that last round, we accumulated about 21% of adjustment factors, right? So an average of 5% a year increases that aren't reflected here. That's been a historical adjustment factor. Is there any reason to think that would be different going forward?
Well, hopefully there's not a pandemic in the next 5 years. I would hope for that. I'm sure that had a significant amount. The California, the market in California, the power supply market and costs in California and CAISO have about a lot of volatility in the last several years and have moved away from what was relatively stable. And so that's why you see a lot of those cost adjustments. Obviously, the war in Ukraine as well, changing natural gas prices, all those world events are influencing those numbers. One of the other elements which I showed, I think, on, sorry, the slides are back up, but I was going to look at the table I was showing you, the load forecast. So way back in 2018, there was another load forecast. So forecasts are always incorrect, right? So that load forecast at that time had certain assumptions. And so when or if that doesn't materialize and load is actually flat and there's not much growth, that continues that upward pressure on rates. So there's a number of factors, not the least of which has been the power supply costs in the market in California.
Sure. Yeah, and the load growth was my next question. And are we using the same assumptions for the impact of electric vehicles and building electrification for this forecast as we are for the IRP?
No, they are different, and there's reasons for that. And I'm sure Mark will want to chime in on this. But for an IRP, you're planning for a worst case, or what's the worst case capacity that we will need, because you can't build a power plant in like 2 months. It's usually 2 years or so.
Sure.
So you have to plan out for those more managing and mitigating those risks, and so the more the worst case scenarios. In the COSA, we're trying to plan for what we actually think the load will be dialed into with electrification, with EVs, with CEC forecasts on adoption, and so on. And so the load, as you saw, it was fairly flat with just incremental growth. And I think, what we have experienced in California and other places is fairly stable loads that aren't really increasing or decreasing too much. We've seen actually what we call demand destruction, load destruction in many cases with the advent of a lot of DER, so people putting solar on their roof and energy efficiency and LED, everything under the sun, that all works well and it can be cost effective, but it decreases the load. So as that stuff is adopted at higher rates, that puts downward pressure on the load. And so while the load is a lower projection this time around, it's I would say, expect it's more aligned with what we expect reality to be in EV adoptions and electrification within buildings.
And if we were able to drive more load growth for good load growth, not, wasting electricity, but transitioning things that were fossil fuels to run on electricity, that would actually help reduce the rates for everybody, right?
Correct. The more load, the exact opposite effect. As it raises, that generates more revenues.
Yeah. It seems like maybe for generations we've been telling people to use less electricity, and now maybe we want to tell them to use more electricity, but for certain things and at certain times of day, right? So big messaging shift there we have to deal with.
Absolutely, a big paradigm shift in the market. We've got, lots of green energy, and the thought is to bring it, obviously, transition those fuels into clean energy, which may mean load growth when we've told people to use less. So
Sure. And then the last question I have is, when does step 5 happen on your 5-point plan?
we're in the process of that. We just received the council, approval or endorsement of that 3-year phase-in. We needed that before we could actually start designing rates. So we actually have initial draft rates designed. We're going through iterations with TWP leadership on some policies around the rate strategy.
Mm-hmm.
So one of the elements we have to consider is Prop 26. And so that impact of how quickly we get to the cost of service.
Can you explain what Prop 26 is?
Prop 26 is essentially you can't directly subsidize different customer classes. So there's a Prop 216 on the water side, same thing. And so it's if you've performed a COSA, you must be working towards those COSA results. So on that last slide where we show the system average and the differences by class, you can't knowingly subsidize residential with commercial rates by like 20%. Mm-hmm. You have to be working to end that subsidization.
Does that only apply between different classifications, or is also within classifications like large residential user or small residential user?
It's just within the overall customer classes.
Because it seems like there's a lot of policy that's kind of buried in that very fine-grained nuance of how do we set that rate and how aggressive are our tiered structures, and do we engage time of use? Is it optional? Is it mandatory? And I want to make sure that doesn't get kind of buried in the weeds here, because we have a tremendous lever there to drive consumer behavior, and we need to flex that lever.
That's true. These are the costs, and we transition in that step 5 to pricing signals. And so those pricing signals can give information to customers on when to use, how much to use, and so on.
And just a procedural question, will that come back to this body at some point before it is adopted or recommended to the council? Or is this our opportunity to discuss that?
Good question. I'm not sure if logistically it would come back to the commission, because we need to get it adopted by November, December. But we've been instructed to look at time of use. So we would be looking at time of use. We'd be looking at voluntary time of use first, because that's to get people accustomed to time of use. But time is of the essence. So I'm not sure if it would come back, but we can come back and explain our positions to this commission. But I don't think it'll be coming back.
Okay. Well, at the very least, we would appreciate that. And for my 2 cents, since this may be the last opportunity, I think that we talk a lot about equity within the city of Glendale, and this is a city of haves and have-nots, and we all live right on top of each other. And one way to square that is with more aggressive tiering in the rate design. And we recognize that there's a fundamental basic human right to a certain amount of water, a certain amount of electricity. But the electricity it uses to pump your pool pump is, a little bit more discretionary maybe. And perhaps that should cost more. So I think that would be a very reasonable approach to take. And you could accomplish that with more aggressive tiering. And then similarly with time of use, at the very least have a voluntary option, but with the goal towards phasing in a mandatory requirement. Because if our goal is to give our customers the same price signals that we deal with as a utility, right now there's a big mismatch there, because customers pay the same amount regardless of when they use electricity, and we have a very different situation at the utility side.
I totally agree with you, but I think that if you're trying to promote EVs, that would skew your tiering because you want people to shift away from gasoline engines, internal combustion engines, over to electric vehicles. And if you charge them a very high price for that electricity, they might not make that shift.
Sure. And maybe there's some carve out for an allotment that's excluded from tiering for electric vehicles or something like that.
Right.
I mean, I'm sure other utilities have gone through this rate restructuring since EVs have become popular, right? So, and then since this is a COSA that will last for another 5 years, is that right?
That's correct. And that doesn't mean that if there's a market change in our situation that we can't run a new COSA, because we ran a COSA in 21 in preparation for the repower, and that didn't materialize. So we didn't finish the rate structure because the large project cost was not going to materialize. So we moved it out to 23.
Sure. Well, anticipating that horizon, I think another emerging technology that will probably be fairly commonplace in 5 years is bidirectional charging of electric vehicles. And we should anticipate to what extent we want to incentivize or credit customers to do that, similar to the way we do with rooftop solar, where it's kind of time of day agnostic, or do we want to have it be more dynamic? So I think we should anticipate some of those things too.
Totally agree with you. And I think to add a little bit to that is we in 2023 are anticipating what's going to happen for the next 5 years. If it doesn't happen, we have these adjustable rates that actually can go negative, right? So it's not just, it's not a way to add to the bill. It could reduce the bill. And if that gets out of whack, then we just run a new COSA, reset those adjustables. Dare I say a negative rate impact, but you could have a negative rate impact, or the what you see in 25 and 26 could be something much less, which is why we want to do the 500 million in 3 increments, because we didn't want to borrow money that we weren't going to use for 2 years. It just didn't seem to make sense at this junction in the financial institutions.
One more question on slide 16. There's the residential, small business, medium business, and large business. Those are not the classes, right? If I recall, the COSA had many more classes.
Well, there's a couple more classes, but those are the critical ones: residential, small commercial, medium, and large.
In the residential, there was the single family, there was the multifamily.
Well, that may be the case in water, but in electric, they're consolidated into the overall residential class.
Has that always been the case?
Since my involvement in GWP since 2018, it has.
I mean, it sounds to me the cost of delivery connections to one home or a block of single-family homes would be much more than to one multi-unit residential building that has 52 units in there. So I don't know why the cost of delivery should be the same, the base rate. That's, I mean.
Yeah, they're fairly similar, and then there's volumes of information that have been published on how to create customer classes. Their usage profiles are some of the most critical pieces on how they use power or electricity throughout the day, and those are fairly similar. There is a little bit different infrastructure at times, connections between a multifamily versus single family, but the way in which they use the power is very, very similar.
Yeah, but we're dividing this on how much they use and the base rate, which is the cost of delivering that to them. And it sounds to me the cost of delivering to a whole block of single-family home with all the wires and maintenance of those wires cannot be the same as the cost of delivering to one building that has almost as many units as a block of homes. And since we're dividing all this, we're separating the costs from the cost of delivery, the actual use, and what have you. I mean, if it's good for water, I don't know why it's not good for electricity.
It's the consumption levels will be lower in a multifamily versus single family.
Exactly.
So you'll see different bill totals, for example, but the way in which they're using the system is similar.
Is the base rate going to be the same for a single family home and apartment?
Yes.
The base rate is going to be the same for those?
The actual rates in the tariff, yes.
Not the rates of the electricity per kilowatt, but I think we're charging a base rate, saying just to put the wire to your house is going to cost you $20 a day, $20 a month. And it's going to be the same whether it's for a single home and an apartment unit?
Yes.
Doesn't sound fair to me, but that's not what we're discussing at this point, so I'm just pointing that out.
Maybe the explanation for that, or some explanation, is that it's a function of the kilowatt demand rather than the length of wires or number of poles that really drives this?
Yeah, the balance of those fixed costs, like the wires and the poles, it can be somewhat different for a single-family home versus multifamily. That differential is a small piece of the overall fixed cost, though. If you recall the breakdown of the costs, like by function, the multifamily is really going to impact that customer bucket more than anything, and that's one of the smallest buckets of the $307 million.
I mean,
So the change, while there can be some differential there, it's pretty negligible in the grand scheme of things.
I mean, alternatively, a multi-unit building could be treated as a small business, especially if they're metered all together.
Yeah, and we're seeing those rates actually surpass at times residential. So that would actually be worse in some cases.
But I mean, I'm looking at this, the numbers are the highest increases in the single family, right?
Correct.
Yeah, okay. I just want, when you're doing the CASA, to be cognizant of equity, that's all.
Sure.
Okay, any other comments? Okay, next on the agenda?
Next item is oral communications. Oral communications, discussions are limited to items not part of this agenda. Each speaker is allowed 5 minutes. Commission may question or respond to the speaker, but there will be no debate or decision. The general manager may refer the matter to the appropriate staff for investigation and report. Commissioner, General Madera, we don't have any phone calls.
Okay, is there anyone in the public?
I don't have any cards either.
Okay, so the gentleman has a comment. Does he need to fill out a card first?
Yes.
We have record attendance in person today, so we want to make sure you guys get an opportunity to speak if you'd like.
Okay. Okay, Mr. Brady? You can, want to come up and speak?
Commissioners and Mr. Young, we've had correspondence together. I live close to Grayson, and I wanted to bring up a couple of comments. This is pretty overwhelming. But I also wanted to say, as far as the rate increase, I'll be very specific. I know we're looking at 14% in January. They've neglected to tell you, or someone's neglected, that in July, they will also increase it an additional 11%. So over a 7-month period, the total increase will be like 25% to July 2024. That's very overwhelming. I'm a property owner, single family, in the equestrian area, and 25% is just a lot. And it makes it appear that somebody isn't paying attention long-term, where this is, you guys, the utility is having to charge this much. And I know we discussed as 150 million in the savings, but I would think when planning ahead 20 years ago, and we may have to replace this, that you start making smaller rate increases, putting money in the bank. So when you have to spend $750 million to update and upgrade, you've already paid half of it up with your slush fund. So I'd like to make that statement. And on the water side of it, our drought surcharge, and it wasn't mentioned, But I always thought when you're trying to get people to use less and then you penalize them with a drought surcharge because the revenues go down, maybe during good wet years, you charge a $5 additional fee, put that in the bank, and then you don't have to penalize people for doing the right thing and saving water during our drought years. So those were my main comments. Does anyone have any questions about my statements?
Typically, we're not supposed to respond to comments, but you are right about the overwhelming rate increase. We've been trying to do these projects since 2018. Had we done them in 2018, the picture would be very different.
And also as a final comment, which I guess you go downsizing Grayson to 58 megawatts from the 250. If we had 99% supply from ourselves, which we couldn't use and we could sell to LA or Burbank at the cost savings of the Glendale customer, that would have been forward-looking, I think, in my opinion. So thank you, gentlemen and ladies, and you have a good afternoon.
Thank you. Okay, there's a Mr. Walworth.
Figured I came all this way, I might as well say a few things. I thought this was going to be a community meeting, but I guess I misread the email. This was just a presentation, sort of a repeat of city council with you guys instead of city council. The question of, why, or I know you're not going to answer this, but why we were told this was going to be the Shoal and Grayson were going to be no increase. It was going to be paid for out of the reserves, and then here we are. I understand it's some accounting acrobatics that I don't understand totally, but that seems a little disingenuous. And if we were wrapping some renewables in and some new movement towards clean energy, I think that might be certainly an easier sale for me. I would buy it. I'm not going to be paying much more because I have solar on my roof, but I think that it's going to be tough to sell this to the public, and especially those of us that want to see a green energy future. Let's see, what else do I have to say here? I think that's about it. Thank you very much, and feel free if you want to explain why we're increasing when we said we weren't. Thanks.
Thank you. Okay.
President Jamatarian, we do have one call.
Okay.
Alan Dish, you're on the air. You have 5 minutes.
Good evening, GWP Commission. My name is Alan Dish, and I am calling to express my thoughts against rate increases. I would like to express my solidarity with the two gentlemen who spoke before. I would like to thank you for the opportunity to address you tonight. I admire the humor and the knowledge expressed during the meetings. The fact that you receive so few oral communication is not because you are failing. On the contrary, it is a sign that things are functioning. There is an anonymous, efficient bureaucracy taking care of things in the background so that I can live my life, read books, watch movies, call the city. While I welcome the upcoming GWP workshops, in general, I am against the idea of being all the time actively engaged politically in my local community. I don't want to be participating all the time. I would like to have the appearance of free choice, but I would like to be told discreetly between the lines how I should choose. So again, I'm calling in opposition to the rate increases because I feel compelled to do so. However, I understand that whichever way you decide, we will have to accept it. I am also not necessarily against more state regulations with regards to ecology, which I take very seriously. We have a unique opportunity to electrify every roof in Glendale, which will require more, not less, state. We will also need voluntarism and thinking outside the box. This is why I proposed to City Council as a joke to capitalize on the fact that Armenians like myself wear dark-colored clothing so much. We should capitalize on this by directly installing solar panels in our clothing so that we can charge our gadgets independent of the grid. So to conclude, really, don't raise the rates because the trash rates were just increased, and this is because Shoal landfill is closing. I think if we're getting more power, why is the price going up? Thank you for the time.
We have 2 more calls.
Okay, thank you.
Gustavo Berno, you're on the air. You have 5 minutes.
Dear GWP commissioners, public officials, and esteemed members of the public, my name is Gustavo Moreno, and I'm an individual member of the Stakeholder Technical Advisory Group working on the 2024 GWP Integrated Resource Plan. My opinions are my own, and I do not represent the full group, GWP, or its consultants. I would like to provide public comment on the potential acquisition of natural gas turbines due to the electric rate increases and the 50-megawatt shortfall. A 30-year, $500 million bond at 4.25% is a total of $885 million. That's $385 million in interest alone. Let that sink in. Glendale residential electric rates will increase by 42% by 2026. Under this scenario, EVs will lose significant fuel cost benefits when compared to hybrid and ICE vehicles, decreasing electrification assumptions. Gasoline costs are only high due to the war in Europe and OPEC plus supply reduction. There is plenty of supply. If OPEC and other oil majors think their product might be threatened, they will lower prices to protect their balance sheets. Not only is this a basic business principle, it is also very important to OPEC, since those countries rely on those revenues from conventional fuel products for their state budgets and economies. There is still time to make changes. It only takes courage. I continue to recommend using AQMD Rule 1135 before December 31st, 2023 to acquire 50 megawatts of new combined cycle natural gas turbines like the Siemens SGT-800 with an HRSG or 2 Wärtsilä. There is no clean energy, only degrees of pollution. When considering the arbitrary social cost of carbon, solar panels are at least 3 times more carbon intensive than the IPCC claims. This is because 80% of them are made in countries that use coal to produce them. A natural gas turbine is only 8% more carbon emitting than a solar with battery system. Solar with storage is really only good for local emission reduction. However, not only does solar and battery system have a large carbon footprint, it is nearly impossible to escape the slave and child labor used to produce them. For these reasons, solar is not an economic or ethical solution at this time. The world is increasing its use of traditional fuels like natural gas, not decreasing it. Since Europe has reduced its imports from Russia, they have reactivated regasification projects and developed new ones. This has led Europe to becoming the primary destination for U.S. liquefied natural gas exports in 2022. Natural gas sells for almost 4 times the cost in the international market. A good reason major utility companies lobby for its reduction in use in California. This policy has reduced the local supply and has raised electricity prices for consumers. Electricity prices in the state normally follow natural gas price trends because the natural gas units are often the marginal source of generation in the California ISO. Fortunately, we do not need to change our long-term objectives on climate change and greenhouse gases, and we should remind ourselves that our thermal generation will assist California's transition to a cleaner carbon future. Using gas is an actionable way to reduce CO2 emissions expeditiously, as seen by one of our energy resource providers, such as Intermountain Power. Thank you. I respectfully yield the rest of my time.
Our next caller is Damian Sullivan. Damian, you're on the air. You have 5 minutes.
Okay, thank you very much, everybody, for taking my call. I actually came there in person tonight, and I left the meeting because of the confusion of processes. So I wanted to actually speak to you tonight, and I have emailed the various council members as well about the process involved with this, which I think has been executed poorly. I, like many residents of Glendale, woke up this morning to a mass email with a header about upcoming community meetings on proposed rate hikes. That was the header in the email. I opened that email to find information from this was a GWP generated email that went to everybody in town. I opened that email and there was a bulleted list of upcoming community meetings about this proposed rate hike. And there were 3 meetings listed, of which tonight at 4 o'clock was one of the meetings. Now, if you want to look at it in granular detail, it mentions commission meeting, but these were listed in an email about community meetings, and they were bulleted separately as the upcoming community meetings, which already is a process that sets apart a reaction from the public that an item that came up as early as last week is now having a community meeting that you're being notified at 9 o'clock in the morning, a few hours in advance of a community meeting in the middle of people's workday. I showed up to find out that it's actually a commission meeting, but like other people who have spoken tonight, who came also believing it was a community meeting with Q&A and feedback and discussion, are disappointed to find out this is a commission meeting upon which an item 4D, merely at the very end, is a presentation that has already been presented and is already online. So there's no community involvement in this, and there's a feeling, I think, on my part and other people's parts, that this was ill communicated, and it was communicated as if this were a community meeting. And if this rate hike is going to be affected, it has to be affected with transparency and earnestness and a feeling of buy-in from the community. You're not going to achieve that by holding community meetings that aren't community meetings, or holding them at 2 o'clock or 4 o'clock in the middle of people's workdays, or trying to change the schedules of when the rate increases go and say whether it's this percent, but actually it's this percent, and a few months later this percent. The citizens of this city want transparency. They want to be engaged in this process. Council members get up at the meetings and they speak about how there isn't buy-in on something like Shoal biogas plant or this or that thing, and everybody fights for community outreach and information. And then we do things like this where it's confused. I came today, like others, thinking it was a community meeting, found a commission meeting with an agenda that had no itemized public comments on the agenda, only non-agenda public comments listed on your printed agendas, on your online agendas. So I came and left because I felt like I wasn't going to get to speak today. It was only because I called the online line and double-checked and said, can I speak about this, even though it's not in your agenda? This is not the way that you do this. If we're going to do this, and you're going to try and sell this to people, and you're going to try and convince the public that they should embrace a 10%, 11%, a 30%, whatever you want to call it, at Christmas time when nobody has any money to start with, you're going to have to do it the right way. You're going to have to be clean, and we're going to have to be better at communicating. And this is not the first time that I've tried, as a very engaged citizen, to follow up on things at various departments of the city to find the packet is missing or the information is nested in some other hidden place. There has to be earnestness to this process. There must be. This is not some small, oh, by the way, thing we're increasing everyone's rates by an enormous amount of money. It may be justified. That's for everybody in the city to speak to and engage the citizens and decide together. But we have to communicate effectively, earnestly, honestly. Otherwise, you're going to sow more cynicism on the part of residents who feel you know, there's enough people walking around who just want to say we have a corrupt city, we have this. I think we have a great city, but let's all have clean hands, do it together, and do it right. Thank you.
President Janazarian, we don't have any more phone calls.
Thank you, and thank you to all the speakers. Next item on the agenda.
Item 6, agenda forecast.
So it appears that in November, we have building electrification, community outreach funding, customer service update, electrification of fleet, and the 2024 integrated resource plan adoption. And if I may make a comment about one of the callers or one of the community members' comments as to why the rates were high now when we were promised 0 rate increases. In 2018, we were going to pay for Shoal Canyon in cash because it was $34,000 and we had that, $34 million, and we had those funds. We were also going to be able to offset power purchases once that generating facility was up and running. And we're losing about $7 million a year by just flaring that gas. So that comes at a cost because power procurement is extremely expensive. Back in 2018, the cost of the summer energy on peak in the California ISO wholesale prices were $44. And last year they were $204. So you can see that extremely expensive energy. Back during the 2018 repower of the 262 megawatt power plant, our goal was to be able to get the best available technology, offset the cost of power purchases, and then utilize that resource to offset any deficiencies in the state by marketing that energy and reducing the cost to the ratepayer. Subsequently, council indicated that they didn't want to put into the market, even though the marginal heat rate unit of that of Q3 is much more polluting than that of the new best available technology option that we were proposing at Grayson. We were directed that we weren't to do that. So we also reduced the 262 megawatt power plant down to 53 or 58 megawatts of 3 Wärtsilä engines with a capacity factor of 14. So we wouldn't be able to use that resource to try to offset the cost of that project. So that's why, and I'm sorry, that's not only why, but most importantly, the cost to borrow money in 2020, the Treasury note was less than 1%. That was when we were proposing the 5 Wärtsilä engines. And that would have made a huge impact on, or a huge reduction in the rate impact that we're proposing now. Right now, we're looking at a 4.25%. So we're going to borrow $500 million at 4.25% as opposed to borrowing $500 million at less than 1%. That's the effect of the rate increase. So I just wanted to be clear. I don't like to tell you so, but these are the things that we've been trying to get passed since 2018. I thought that this was going to be a much faster process, but we're on our way, and we're going to go forward. Thank you.
I think in simple terms, in 2018, we were buying a Honda Civic. Now we're buying a Tesla at this point. It's much more expensive, different technology, costs much more.
Just on the current agenda item for, it feels like we ought to try to do a little load balancing between November and December. The November agenda feels awfully heavy. Not sure that the the capacity wouldn't be overconstrained. We might be here till 8 or 9 o'clock. So
You think we'll blow a transformer if we try to do all that?
possibly. So I might suggest that a couple of the items maybe be shifted over to December.
I would suggest the fleet electrification. That's a much more difficult report, and if we have more time in December, I think it would give it its due.
Yeah, I think that was one I suggested a while ago, and I'm happy to delay it so we can have a proper hearing. And just wanted to clarify that when I suggested that, I was thinking about electrification of fleet vehicles as opposed to electrification of personal vehicles. So we've already talked about a lot of the programs we're doing for residential customers in their driveways and garages. I wanted us to talk about commercial and government fleets because they have special needs. So that's our city buses, which we talked a little bit about tonight, even organizations like the Postal Service. You know, there's a big post office right a couple blocks away. Maybe there's 50 trucks there. What happens when they all go electric? Are there other commercial fleets of plumber trucks and things like that? So that's kind of what I was thinking of getting at.
I see. I must have misunderstood. I thought it was our City of Glendale fleets, but we'll have to look into.
Certainly our fleet is an important one, but it is not the only big fleet that will have an impact on our planning and operations. And as Mr. Scorza explained, the impact of the bus fleet on our distribution grid planning is significant. There may be just as significant of impacts if the Postal Service goes electric, or if, you know, recycling trucks go electric, those kinds of things.
Understood.
Any other suggestions for the upcoming agendas? No? Okay, next item, please.
Item 7, adjournment.
I move.
Second.
And we are adjourned. Thank you.
Thank you, everybody.